Oh yeah, es un problema.
I don't understand things. Yeah, it's like one-on-one, not a. Yes, sir. I'm not really so much. So it's the record. Yeah. What it is. Just one person. Oh, that's good. They have to pick up with people. They're getting well browsing. But it's not the like what the national. We did this and
You got it? Yeah. Sure.
Yeah.
Are you ready to do the page, right? I'm gonna be selfish and eat this.
Okay. So what am I? No.
Yeah.
Not yet.
All right. I thought you were like, I'm like, fuck out of here.
I don't know here. I'm leaving.
Right now?
So.
All right.
Take it back to the first box.
All right. All right. Let's get. Anybody that's in the back that wants to move forward? A lot of seats up here. Okay. Welcome to the third day of the OpenSIPS Summit 2023 here in beautiful Houston, Texas. I want to take a moment to also thank, wow. Yeah, all right. We have some sponsors that are not represented here and some sponsors that I missed. Flavio, are you in the room? Flavio is from SIPPulse. He's also an amazing friend of OpenSIPS. Flavio was one of the trainers of my first, or actually of my own, OpenSIPS certification. I don't know if I dropped this.
Love you, Alex.
This is not only to come and help us, but he also sponsored. I feel terrible for missing some of these people in the last couple of days. I'm very sorry. I'll make it up to you. Bogan has midgets.
You away.
Our friends over in Athens, Greece, Voiceland, Mr. Vasilios.
Happy birthday.
Happy birthday to you. Happy birthday to you. did you notice it was around the ether of Athens? Voiceland was also a sponsor this year, and I did miss them the last couple of days. I feel terrible. But Vasilos is a cool guy. He was with us in Athens. He does some really cool stuff. Get a chance if you're looking for anything in Greece, check him out. It's Voiceland is the name of his company. Who else did I miss? Well, Jonathan wasn't here, but he does have a banner. Jonathan Hewitt from Connect CX was gracious enough to be one of our sponsors as well. Maybe not him, but his company. He was going to be here. He ran into some snacks, let's just say that. But they helped us out, so I want everyone to give them a round of applause for helping us out. Thank you. Okay, that's our sponsors, right? Okay, so our other sponsors, wow. Testing. As of last night, our other sponsors are the local liquor stores.
Alex.
Yeah? No, I got P yesterday. Yeah, they've been a great sponsor. Which is why I'm feeling the way that I'm feeling today. Anyway, without further ado, we're going to kick off our design clinics today. Max of Solola. He's going to be talking to us about developing with OpenSIPS on GitHub.
Yeah.
Take it away, Max.
Yeah. Hey. No, it's fast. Hey everyone. Yeah, as said, my name is Maxim Sobolev. I'm with City Software, and I've been developing with OpenSIPS and for OpenSIPS for quite a long time. So I just wanted to share.
Max, sorry to interrupt. Coffee is here for the people still waiting for the coffee.
Okay, so yeah, and I just wanted to share some of the helpful tips. Maybe if you're just starting up on that path, or maybe you're already very well on it. That might be helpful to other people to kind of smooth a little bit the process. So first of all, few quizzes, I guess. Who here doesn't love open source? Okay, that's good. So I'm in the right place. But we use it not because we love it. We use it because we're trying to solve some specific problems that we have. And often it happens like you're working on a problem, you're looking for some open source solution to this problem, and you find that it's not quite, it's like 95% perhaps that is there, right? Like you have this decent piece. And obviously, well, if you have knowledge and all that, one obvious solution is just go and develop it yourself. So, and then you will basically need to figure out how to do it and how then interact back. How many people here are using GitHub? I guess everyone has an account, right? How many of you have OpenSIPS repository for your private account or company account? How many here are using like GitHub Actions? Okay, that's cool. Okay, so then basically the plan of attack today will I'll go around through slides quickly just to give a brief overview of some of the common points. And then we'll do like practical on-hand example. I recently started working on this module that I was talking about yesterday, and basically did some continuous integration created for it. So we'll use it as a practical example to show folks how you do it. So basically, as I see, not everyone like forked an OpenSIPS repository, and it's actually I think if you're developing anything or trying to fix some problems, you definitely need to fork a repo because along with it comes stuff that is built by OpenSIPS team and myself in particular, which is basically you get all the GitHub actions. So as soon as you fork the repo, it's basically it can also create automatically the same set of GitHub actions for your own account. OpenSIPS projects while developing the code. I can show you some examples of, for example, working on my laptop for streaming. So this laptop is not so good to hook in. Not good? I was talking about when you clone the repo, you also get all the GitHub actions. So here I have my own private clone of OpenSIPS repo, and here basically I'm working on this new feature which adds three proxy support. And you see my commits into this private repo that triggering actual good GitHub action runs. So basically, you automatically get your code that you're working on checked. And speaking about GitHub actions, we developed several so-called pipelines, and basically those are kind of set of specific tests that will be done every time you make a commit. So basically, there is line CI, which basically just does the build of OpenSIPS. Yeah, so basically here inside here we have built all sorts of different compilers, and we also built on two different versions of Ubuntu. So basically you get your code automatically verified and builds with all those different versions of compilers. And then we have also multi-architectural build. And this is also will build your code on all those different architectures. So it will be triggered normally every. Also set of unit tests with we will slowly building up, which basically builds specific bits of code to test some specific C functions in But anyway, the bottom line is you basically don't need to do anything. You just fork the project and you already have all sections enabled. Benefits and then another step that I highly recommend when you start working on fixing some bug or working on a feature is create a branch. Take some probably whatever, like you can either take some stable branch if you're interested in the main branch, master branch of OpenSIPS, and create a branch. So basically, sometimes you start working on something and go away to something else. At least when you come back later on to work on this again, you get it logically separate from other stuff that you might have in. It also helps later on when when you finish work. Usually you work on this feature or fix, and then you finish it. You want to make a pull request to kind of get it to my line. Then having a branch would save you time, like picking up some spot. So makes makes a lot of sense to it. Right away. And one thing that I particularly, which is particularly important, if you're working on something like a big feature that is expected to live for a long time, like something like new module maybe, or maybe major functionality for a new module, for existing module. We definitely need to have more continuous integration. So create at least something that would build because we have, as was mentioned many times over those 2 days, we have almost 200 modules, and so like having them tested by the project is not realistically achievable. So if there is like a piece of code that you particularly like, you create your own like private pipeline, or maybe you'll see that it's useful and you can contribute it back and build better continuous integration for OpenShift in general. And the test case, obviously, very useful, especially when you then go back to the project and try to integrate your changes. Like having a test case, it enormously speed up like the interaction, especially if the changes like big or very and that might help. But even for your own development, I can show you like 2 years ago I did quite big work on implementing the RC 750. That ended up in like 3,000 something lines patch. Launched. For that specific development, I even have to create because there are so many like different combinations. various like algorithms and stuff. It's basically get them hand by hand. So we had this on-site project called web tests and create special pipeline in that project just to test that. And it helped enormously because then I created like different scenarios, UAS, custom, like also have several modules of authentication which I needed to factor in. So it's like DB-based authentication. There is anyway, so basically that's kind of my pitch on having some good practices probably apply to any other project, at least major project that you're going to interact with. All of those projects pretty much have continuous integration and on any contributions of having attached to the test case. OpenSIPS is not there yet, but at least I heard at least it's where things likely to go in the future, because obviously it's difficult for the project to maintain all of this pieces of software. And last but not least, after you finish your changes, set of changes, you make a pull request, and then this is basically where kind of like fun part. So you need to interact with. So very important that you put all pieces together, make sure. But anyway, so now, as I said, we'll go through like a little bit of practical test case. I'll create a pipeline for my own modules that I created last month. So we'll go with just going over looking at a little bit under the hood of the GitHub action and how it works. So basically, it's good enough. Bigger maybe? Oh, yeah. So basically, as I said, I already have a special branch for this feature, and yeah, it's quite useful. So, for example, I could immediately uh, just, So anyway, so on GitHub Actions, essentially it's pretty easy. All you need to do is create GitHub workflows. And here you see there are like 1, 2, 3, 4, 5 files, and those files correspond to the pipeline that I was demoing. Just, basically, we have those pipelines here. And then Stale, I guess Stale is some special pipeline that deals with some ticket management or issue management. And here basically you can use for your own project, you can just refer to existing workflow. So for example, we look at the main. Here basically we have several sections. We have obviously some name. Then it triggers. This basically sets some rules as to when this line is invoked. So you can set some filters of particular batch. Stuff like that. So basically, but you can copy like default section. Then you pick an OS that your system will run on. You can run on several OSs or just one. So basically flexible here, and then that's basically declaration of your running environments. And then it comes with a set of actual steps to execute. So there could be like some built-in steps that you can just go to the documentation, read more about this one, for example, just checks out the code. And then basically you specify steps needed, which could be like, for example, get the dependencies, build dependencies, build module, and then you can have some post actions, so that pipeline can, for example, trigger some notifications to happen, so you can have like a SMS message, for example. So basically, this is pretty flexible, and you can create all sorts of distance scenarios. So as I said, we have, for example, another one which is a little bit more sophisticated, and that deals with building stuff on different architectures and so on. But as I said, for your project, you can start with very simple one. It's lines of code. And you guys have any questions? Maybe something. So let's say we want, as I said, we want to make a little example of that module that I built. What do we need to have this achieved? We basically need two things. We need to build custom RTP proxy, and because it's also new functionality on RTP proxy side, so it's not yet available as packages. And then we need to build actual OpenSIPS using that library. Basically, I usually just pick up like shortest, smallest existing pipeline. So basically, which is probably the same pipeline as kind of just copy And so basically you can leave all the stuff like from existing pipeline, but then you can also add your own steps, or you can delete everything. So let's say we build, we keep like existing build structure. But then we want to build our custom module, so we basically add another step. I said we first need to get and here you have like two options. You can either use like one-liner, so just one line is enough. You can put like all your stuff in one line, or maybe if it's just a script. Or I think you can use this kind of form. This, and then you can have multiple commands within the same pipeline. So it's the same step. And it will also go some changes to the system. All those tests will be running in like, I think, some kind of containers, so pretty much disposable environments. Okay. Yeah, for the time being, I'll just disable these connections. Just to test my new stuff. Oops. Check this. And I would also remove, because those other existing pipelines will take quite a lot of time to test, to run. So they don't. Okay, so now if we go back to the, we should see the pipeline. Yeah, so here you see it's built and will dispatch all in a second. And you can actually check out. Okay, not put the correctly. Okay, so we change. I pushed it. Yeah, as I said, the benefit of it obviously that it runs my change on all those platforms, which way just. And you get pretty immediate feedback, so it's. essentially iterate until we get it correctly. Yeah. Yeah, I need to actually check out some modules. And just in general note, when those grow too big, probably better create a script. Yeah.
I have a question.
Yep.
When you add a pipe, do you, it allows you to run more than one command?
Yes.
Okay.
Yeah, it's not really a pipe, it's more like syntax.
Syntax, okay.
Cool. But each command will be, each command needs to succeed in this case. So basically, if one of them fails, both of them fail. Some caching mechanism. So technically, if you have like some big external dependencies, you can use those more advanced features of GitHub Actions to save. For example, here, for example, we build a proxy between externals, and we can, for example, cache it on there are several options. We can key it on revision in the external repository, and then basically save time. Libraries. Okay, Yeah, and it shows here it's pretty good test actually when you build build your stuff in this clean environment, because sometimes when you're developing it, you don't realize you have some dependency. So basically, it gives you that put your code exposure to like a clean environment to develop. And see there is some version, hidden version. Like in this case, I have a dependency of something. Like, proxy. And now we can try to put everything together. We got a proxy, so we can enable the build of OpenSIPS, and as a last step, try to build our module. Modules. Yeah, I think there's some unrelated failure to build OpenSIPS. But in any case, do not hold the next session. I hope I kind of convinced you guys that you can really use Puppet with GitHub Actions very quickly. You don't need to have like anything. Just you can use like existing infrastructure and yeah, try it out, set it up for your project. And after the building, you can also use handset, so you not only build your module, which is at least very good, but you can also test, you can create actual test case, which would use tools like aside stuff to set some calls and make sure that your code actually. That's, I think, it for my little demo, and hopefully you'll find it at least somewhat useful.
Thank you, Max. I'm not sure if you know, but Max is the one responsible. He took the burden of the CI integration. OpenSIPS project on GitHub. So the CI tests, which are done after each commit, done by him.
Oh, they will help.
So yeah, big thanks for that. He's more or less really taking care of that part of the project. Now, next workshop we have Liviu Kirgu from the OpenSIPS project. And as mentioned in the first day, in that section about the OpenSIPS ecosystem, about having multiple projects actually and software, pieces of software are gravitating around OpenSIPS. He will show you today about the calling API. So how you can control calls that you have by using a very nice REST API. And also some quick insight about the last control panel release. So, Liviu, it's all yours.
Thank you, Bogdan, and good morning, everyone. Good morning. I'll have a short presentation I'm not sure how short it will be, but to discuss a bit about how the API is structured and what we had in mind when we wrote it. Small correction to Bogdan. He said it's a REST API. It's a XML RPC over WebSocket right now API, but we have gotten a few requests to turn it also in. So to give it some REST interconnect capabilities, but I'll get into that towards the end. All the status there. So we'll be going through the architecture, how you can write your own clients for the API, and what scenarios we have right now, and what room there would be for more of them. And also you can view this the scenarios we are going to discuss as kind of an appetizer for the more interesting ones, which first the demos with the backpack API. Because right now that is a quite powerful API and allowing you to build lots of things. Here, basically, we are using some, as you will see, some transactions, a bit of dialogue and interaction, right? Because the API will interact with OpenSIPS, and that's how we achieve these higher level call flows. So that is the main purpose of the API, to build, to to extract these high-level call flows such that your new scenarios and other kinds of interactions, maybe new events, let's say, and scalable, right? Since it's Golang and it's quite fast, you get a lot of ways to achieve asynchronous processing. On GitHub, that's the address /OpenSIPS/call-API project. And this is a kind of what it all looks like when we piece it all together. There is the first layer of interaction with a middleware. If we were to use maybe some web clients, we would have gone with a REST API that would be more straightforward, hence the long-lived WebSocket connection we went with. We run commands and we get back events. You see, again, an optimized interaction, right? It's UDP-based. Not sure, have you worked with the UDP datagram module for running MI commands over UDP? So the cool thing about it is that they're asynchronous. For example, think of DR reload, right? Reload the trigger reload. And the result instantly. You don't need to wait for the command to complete. So that's one advantage you could say with Git. If you run multiple reloads, they will still wait after one another, but hey, at least your application doesn't lock. So we have this UDP-based interaction also with the events. They come back from OpenSIPS as the complex scenario takes place, right? At each stage, whether if it's a transfer, if it's a hold, on hold, or that kind of stuff. So on the first leg, as I was saying, with the application interconnect, there is not that much blocking. It's JSON RPC based, and you get these updates, these nice updates in the application. And some samples on how it looks like, the JSON RPC. You're probably familiar with it. If not, it's just a few, let's say, unblocked. Standard stuff, like cookie cutter parameters, right? You need a JSON RPC indication, here, for example, we do a call start, which has two parameters, right? We extracted it that way. And what we get back from the API is also a JSON RPC notification. Not also, is a JSON notification with a status and some data about caller calling. On the back end, we have the datagram interaction and the API which does these commands and gets back the event. So pretty much what it relays further to the application. I have to say upstream. Always thinking of SID parity. So here are some sample datagrams being exchanged. The first one you can see, it's a TUAC command launching some invite for the click to data scenario, and then there is a call transfer event. All kinds of useful stuff, right? Call ID, the delay, the destination. And maybe some tips on writing the clients. All you need is just WebSocket support, which is pretty much available in any language you can choose to use. JSON RPC is easy to set up, and it's important to you can make full use of a single WebSocket connection. You can reuse it. You can bidirectionally reuse it as much, because there is no, we take care to include the command ID so you can mix and match the events as they come to you to match them to the pending requests, right? Because you might start, you might have, well, in big volume scenarios, yeah, there's going to be a lot of chatter happening between the middleware and the API. Example, yeah, we have also an example, place to start if you want to start building this stuff. And yeah, popular request was to have just a web API, just REST, and have some webhooks. And we haven't gotten to that yet. We focus on other stuff, but it might be the right time to make that happen. So, pull request is also welcome. I will happily review it. Shouldn't be that hard to set up. Yeah, it's Golang after all. It's quite concise. It's a nice language. You can quickly build. And last, let's go through some scenarios before doing the demo. These are kind of all the commands that are available right now. You could argue that it's not a lot, but you know, it's a good place to start. It all begins and ends, right, with call start and call end. And we added some hold, on hold, and the blind transfer methods as additional scenarios. If we can take a look at the call hold, you can that the interaction notifies you at each stage of the hold, because both participants are going to be both. This is all controlled by OpenSIPS, right? It's being in the middle. Here it's on the left side. It controls both legs, and as each leg performs the hold, you get two events. You get a start and a success once the re-invite is ACK. And this one is more interesting with a click to dial scenario, which we are going to do in the demo, where we initially set up. So the idea is to set up a call between Alice and Bob. But we do all of this, right? There is no dialing happening from any of them. It starts from the middle. So what we do is we establish a dialogue with the first one from ACBLG. This is happily abstracted. You just, on the app side, target and destination, which is quite handy. And right, and then we blind transfer it to the colleague. OpenSIPS will then send the switcher and close the session. And hopefully, if the client supports refer, the click to dial scenario will happen. A new dialogue will take place between them. Yeah, I'm not joking with the hopefully, because for the demo, I've only got one direction to work. For example, we're going to be using a linfo and a Zoiper, and the Zoiper just, yeah, not responding to the refer at all. It's not handling refer. Yeah. Also worth mentioning about a new OpenSIPS module that has these logics built into it, right? If we go back to this. Part is all a scenario in the call ops module. So these go hand in hand. If you use the API, you will have to load the call ops. So these become available via MI, right? The call commands. It's not a back-to-back user agent. It will only achieve these through mid-dialog requests, re-invites, and refer. And you could also use these in the script. So maybe if you ever have these kinds of scenarios, there is no need to loop via MI or anything like that. And also available the CFG. So for the demo, I will fire up some consoles, and we will be performing. See, okay, this click to dial scenario, and well, I will show you I guess the idea is to look at as many perspectives as possible, right? So we are going to take a look at events on one side of the first leg. We'll take a look at the MI interactions on the back end. And as a third perspective, why not look at the SIP as well, right? Because after all, it is a SIP scenario. So yes, we could use these concepts already. But first off, we need to start the API, right? So here I am, I'm already the, let's take care of the fonts first though. How is it looking in the back? Is it okay, I guess? Or can we go smaller, or what do you think?
A little bit smaller.
Like this?
Bigger.
Bigger? Okay.
Bigger.
All right.
Thank you.
Good, good. Nice. So probably the screen, I will just switch between them. On my screen, it's looking bad. Okay. So to start the API, we just is as simple as running this go run, and we just launch the main file, the Golang will compile if necessary. Otherwise, it will just start by default listening on 50/50 port. Maybe what do we need? We need an ngrep, let's say, with this is the MI ngrep. We are typically listening on 888, but not sure how the script works. So I've included 88 as well. Probably that's the one. And also need the SIP trace. So call it SIP trace. And we just start them. So we have the link form ready. Let's, of course, we need to make sure the OpenSIPS is started. I'll also adjust the font here. Should be good. We can start. So here we can dial. All right. So, but obviously we expected to get a call from OpenSIPS now to Alice, which we will answer. And now there is the second interaction, right, where we blind transfer Alice to Bob. We respond to Zoiber, and the call is accepted. So let's take a look at what went on here, because there's a lot of things happening. Let's start with the SIP signaling, but we can digest the other ones as we go. First you will see that this invite loops back. Right? Maybe raise an eyebrow. Why is that? UAC DLG. That is the first interaction, which sent the invite to, we request Alice, right? We cannot invite to, we don't know the contact. We need to to loop it up one time to ourselves. So we enter this OpenSIP script, right? Does that make sense? By the way, if you have any questions, just feel free to ask this. We can make it more interactive. I would happily answer any questions that come up, especially given that, as you will see, there is this attended transfer stuff happening, which we don't want, but it is what it is. So now that we have the invite and it entered the script, we can do lookup location, and we learn Alice's contact, so we route it. For example, here you can see it is on port 58. So there's that. We answer the call then, right? The first interaction, so call established, and now we achieve the click to dial effect by referring Alice to Bob. So let's zoom in on the refer. There is the well-known refer to header, which gives us the pointer to the callee, and you might notice this OS ID parameter, which is specific to the call ops, and it basically represents the dialog ID. It's just a dialog identifier. It's similar to what you see you create dialog, right? You see the contact, PID parameter. This one is OSID just to avoid confusion. But it's helpful to have the reference to the dialog. So we refer Alice, and as I was saying, here's where the weird thing starts, where it first tries to put us on hold, right? It's like a attended transfer. So yeah, you see this A equals central, right? SIPS obviously cannot, is not ready to handle that. It would have preferred just notify and to handle okay and just close the dialog. So as we replied, as we 481, the lin phone, now it closed the dialog. So now OpenSIPS tries to close it. It also replies with 4.
It's typical interrupt issue.
Thing happening there, but at least the second call worked without issues, right? So it delivered on promise and it refers to Bob. So we see here in the second leg of the call, we see the link phone doing good, pulling through its promise. And it establishes the call. This is really unviewable. For a bit, just to see the flow a bit better, I can zoom out, and then I will zoom back in. Yeah, so we got the call established. Maybe let's take a look at everything what happened on the first leg. So as I was saying, we started with not the first leg, sorry, the back end, like right, the interaction between API and OpenSIPS. We can zoom in. So OpenSIPS just responded with a 200 OK, which prompted the API to also subscribe. So now it prepares the call transfer. So it does the event subscribe. This is a for MI interface command. You can subscribe to various events. You can, and the idea is here. Of course, you give it an expiry of how long would you like to stay subscribed, but you also have to give it a socket. Where would you like the deliveries to be sent to? So from the Golang application, we open probably a UDP listener, so we listen on this random word. So this subscription worked. So now the API doesn't transfer, so that's where the refer part happens. And it only needs these few parameters: a call ID, destination, and the leg. And we get the nice notification. Also, you might notice it's on the 40905 port, so our subscription. And next, right, is the unsubscribe. Okay. So the Golang app is nice enough to also remove the subscription. It gives it expires 0. Finally, we close. This is the part where it gets 481 back. We try to close the initial leg with a TUACDLG and we set the by. Notice here, method by. And always tries to send this to lin phone, but the call is already ended. So that was it. And we are at this point where the interaction is performed and the call is established. So I will, thanks to Zoe, I've also installed the CP locally control panel. This is the 9.33 version. Okay, I know. Oh yeah, it's really good. It's I can also increase the font a bit. Oh. And it's meant to run with OpenSIPS 3.3. So if you haven't caught on yet to the convention, the last two numbers represent the OpenSIPS version that control panel is meant to run with. So here it's meant to run with 3.3, but I'm pretty sure we're running at 3.4, but they're similar enough that there are no issues. One cool thing about would anyone be interested in how we set the design? Or are you okay with setting up a CP and we can skip that part? If you're interested in how to set up this interface. Okay, nice, awesome. I will start with unfortunately. Unfortunately, there is no packaging right now. Just install Apache 2 and you're good to go. It's already started probably. Status Apache 2. That's the web. Now the only publish, or rather link the site into the web server so it can serve it. So as you go etc Apache, the way it's structured, there are the sites available and the sites enabled. So if you go to sites available, which by the way this is enabled anyway, the OO default configuration, and you just copy paste that in. So what I had here in the first tab, add this, just grab and copy paste. And all of a sudden you've published these directories, right? You give how to serve them, some directives here, /c for your website. So now all you do is restart systemctl, restart Apache 2, probably with sudo, and that's it. The website is online. So localhost /c, and you get this the nice login window. One thing you additionally need to set up is a database, because now it will confront, right, what you're inputting here. It's the database of users and passwords. So there is, again, we follow the guide. What else we need to do? Of course, I forgot about this step where we need to install PHP, and you'll just definitely get here. And then just the database, right? We need to create the control panel tables, and this is the config schema in MySQL. If we take a look, it will probably contain one entry and something. There it is. So by default, it installs this admin, and we can see the password here. So it is OpenSIPS. And we are. So that's it. We are because it's quite handy. This config db. I'm not sure if it's 2 tips. This is the user password. Probably need to look up docs. Yeah, I don't know what it is. Probably 1 hour or so.
Okay.
So yeah, you will get forever hanging files. Setup again, transfer to the hold. Okay, call on hold. So here. Okay, so we can take a look at the trace. Let's do that in the second dialog. Zoom out a bit. And we can see OpenSIPS controlling both legs, right? It's, since all of this is done from the SIP proxy, we see the A equals inactive. And they both complete successfully. So right now, let's unfold by pushing again. It's hold, but it's a first version interface, so bear with it. So now OpenSIPS unlocks both calls by not providing anything, right? The default is two-way audio if you don't give any. So the call has been resumed. So now as a final scenario, I mean, we can end it towards the end. So I was thinking, let's do is it also interesting to follow the events? Sorry to make all these pauses. So, yeah. not it's pretty self-explanatory. You also get nice, right? You can see a subscription for the event, and when we do the hold, OpenSIPS also fires up the events over to our way. I'm probably not tracing it, so that's why we don't see it actually. So here, because it's a different port, so there's definitely a random destination port, right? Because we subscribe. We see here it's on UDP 40,000 something, and OpenSIPS will use as a source port, a different port. So maybe we should trace all UDP on my laptop to get it to see it. Actually, called removing event called hold. This is a log. It processes it. Yeah. Okay. So now let's do the transfer. Cool. Let's have the call CMD tool. So it's also in the Go project with the API. And it takes three parameters. It takes a call ID, it takes a leg, and the destination. So we will transfer the lead phone to Carol, which is Twinkle. It's the third user agent. But first we need to grab the call ID, so we have it nicely available here in the application. Paste it here. And we should get the Twinkle. Oh, I hit the wrong directory. We should get the Twinkle ring. But the call establishes it. A regular calling, it's playing nicely. Take a look at the city trace, see what the heck happened. All right, so now we see OpenSIPS initiating a refer to the lead phone. And, oh, that's actually the lead phone doing again putting us on hold, right? So it's putting us on hold, and the same thing, right? It did it the first time, it will do it every time. But eventually it does the invite to Carol as well. Maybe I'm not following on the right dialog. Yeah, it's this one. Okay. It's not there. Okay, so that explains the UDP error. Okay. Try again. Yeah. Why is the user agent there is always a maximum chance of failure? I guess we just shut it down and try again. That would be clean. Hey, at least the call didn't work. I can see should see the file. Just like on this leg, we should see it. We see the OpenSIPS buying both legs, right? Both Alice and Bob. But since this transaction didn't complete all that well with Carol, probably Linfo didn't move the call at all. It said, okay, no, I'm canceling this transfer. I'm not buying anything. I'm maintaining the call with Bob. Okay, so we should be in a clean state now. Why not go to the control panel and refresh the dialogues? So we always get this, the hanging dialog for the first click dial, of course. For the second attempt. let's do the transfer, just test the operation and see if it likes it that way. So let's grab the call ID, go to transfer, and fill it in. Okay. So now it established at least without dying. Right, so this is like Schrodinger's SIP user in the server. Sometimes it works, sometimes it doesn't. And we should see, it would be interesting to see how the second dialog was handled. There we go, so OpenSIPS, after the transfer worked. Now, this is all call-ups, right? It's all logic internal to the call-ups. It also takes care to nicely close the call between Alice and Bob, so it buys both participants in that dialogue. So we are only left with the third invite here. Yeah, already have 3 call IDs between Alice and Carol, which is already by. Wait, why did the link phone close the call?
Oh, lymphomas.
Maybe he was getting no audio. That's interesting, actually. So we can count some. What was the?
Why it's so easy to make reliable user agent like soft phone?
Yeah.
Why is so difficult?
But maybe
It's like
it's legit.
it's like magic. Like 20 years, nobody.
No, exactly. That is it. If you look at the timestamps, at 54 it was hacked, and 30 seconds later it closed the call, right? So probably Twinkle wasn't sending audio for some reason. I would need to
Okay.
yeah. It plays nice. I mean, we can definitely not say that many bad things about link phone systems. I mean, Zoiper doesn't, it looks at the reefer and says, you know, butt off.
Have you ever tested
At
it with
least it works.
Have you ever tested it with Jitsi?
With Jitsi?
Yeah,
No, I haven't.
Jitsi desktop.
Okay, Jitsi desktop, that's good. I'll try it. Yeah, so this, probably the events are similar. Right, this is the same method, right? It's the same call transfer that's used in the initial, if you remember, the call start. We also tricked it into achieving the click to dial with a call transfer. So now we did the call transfer explicitly. We specifically transferred caller to Carol. So that means a similar suite of events will be taking place. So probably there is nothing to end at this point. Perfect, right? Requested dialog not found because OpenSIPS has already seen that call close and it gives us the appropriate error. Should we see any more calls? I think we should see one. There we go. We should see the first thing this is a known issue, right? The 481 call doesn't exist on the attended transfer that link phone seems to be doing.
Does it keep that dialogue indefinite until you close it out?
For sure, yeah. Yes. Definitely. The timeout as I was talking about.
Like a certain time, like an hour?
Yeah. Okay. So that was it. We pretty much ran through most of it. I had this additional slide for you in case you're just getting started with Golang. This is all it takes to both install Golang and keep yourself up to date, right? Because these guys from Google, they move pretty fast. I'm pretty sure they do around four months cycle or something like that. They do almost 3 releases per year of Golang. Maybe 2, yeah, that's 2 to 3. So, just a few months pass by and you're already behind the time. I just did an upgrade, and this is all it takes to upgrade your Golang. You just download this tar file, this tarball binaries. Just remove the previous. In /go in your home, go the packages, and in bin go, you just dump the tarball. So those are the binaries of the language. Yeah, and then it's nice. The nice part about Go is that you don't even have to worry. I'm sorry. You don't have to worry about the packages all that much. You just run your app, and then the Go says, okay, I need this package. I need to download this package. And all of the packages just go to /go. It's quite. Yeah, because as a Python user, I was skeptical at first, right? Why delete my packages? Because I will have to reinstall them, right? Such a pain in the ass to. But with Go, it's just dependencies, and they just get resolved. And then you need those couple of variables I put on the left, the environment variables, the Go root, and maybe append the prepend, the Go bin path to your path, so the new binaries take precedence over the system Golang, right? Because there's always going to be, with each, I don't know, with this Ubuntu 22 that I have, there's probably going to be an older Golang that ships with it. But with this technique, we are always grabbing the binaries the latest, even though the distro might not yet have them. References, if you're interested in building more stuff on the API, you can source code, the list of commands, they're nicely documented, as well as their events and the parameters to each of them. There's a blog post also, and of course the call-ups module. And that was the main, what I wanted. I hope you got something out of this and understood what our vision was for the API, right? The idea was to skip you from handling, I'm not sure how to, avoid making you work with these low-level MI commands with the TOAC, DLG, sequential, and all these intricate SIP handling, and maybe pack it into some more powerful abstractions that yeah, you might find easier to work with. And, yeah, also it would help us as well, right? Because once we encourage this kind of abstractions, now we can really work on the scenarios without breaking your application, since it relies on higher level primitive, right? Whereas if you rely on the low level primitives, anytime we make changes there, we break all of your application. So anytime we work on UAC, DLG, just change one parameter, or yeah, make a change there, we risk breaking. So yeah, we hope it is a powerful tool that you can use. And that was it. Let me know if you have any questions here. Thank you.
I guess.
Sure.
So for like the commands that you have on the GitHub.
Yeah. Here, these ones.
It's based out of like JSON format, and just expand upon that. So basically, the commands that you have on the GitHub is coded in JSON, and you're able to expand on it as well as different scenarios. Like, say you want to test session expiry, or something like that. Like the challenge, like a re-invite for session expire, or maybe do like different coding. You want to like say you change, like you get a 488, you renegotiate call with say a different code. The OpenSIPS wants to accept the example, so you can build upon that, right?
So there are some basic primitives that we gave here, like going through the docs here. All right, come.
Yeah,
So yeah, each command is closely documented, both its inputs and its events, and it's JSON pretty much. All of them you give it as JSON parameters. JSON.
Yeah.
And as far as your question on
pretty
being
okay.
able to be
My
more
demo went pretty
flexible
okay.
and
Almost
these,
got
different
like
different
to
scenarios
final
like being
point.
biased with
Like
SDP
almost
and
got.
that kind of stuff.
Okay.
Did you finish
You
it?
have
So you can
to
go back.
make a pull request with a new interaction,
Go
right?
back,
The
okay.
new
That's okay.
parameter, let's say codec or stuff like that, that gets built into, I'm sure if I have the tab here, this kind of, so when we build a request, there is caller SDP or something. Oh, last one.
Is the call SDP?
Call the SDP, there we go. So here, you can maybe include a codec there, so you can interact with it that way, with the new command. But yes, so far it's not possible to do what you asked.
Yeah, but it could be
Yeah.
built.
Yeah, you can always build them.
Almost. It's my own copy.
Okay, yeah, but then,
It wasn't a question, it was actually, it was probably just more feedback towards like, but I think the question is, do we really want OpenSIPS to negotiate on behalf of two gateways, right? Because if OpenSIPS is saying on a 488, you know, list another codec in SDP, the gateway still has to negotiate, like, because it's not doing the media part, right?
well, maybe, but who knows, maybe you are doing transcoding. You might want to help connect that call or do your best to connect
Yeah,
it.
like one client might do the set.
Yeah, it's not something out of the ordinary, I would say.
One more question.
But yeah, unless you do a lot of more work on your side, it's not going to work. So it's pointless to try it. Yeah.
Basically, just understand.
Does your code process maintain state such that you have to make sure you don't kill the process inadvertently, or else existing sessions that are open get out of sync with what's on OpenSIPS?
This session on API will get out of sync with the sessions on OpenSIPS.
But if the go process restarts, does that cause any issues?
Oh, that's a fun question. So, what happens when we restart the API? So, right now we lose all state.
No, the question was if the call itself is influenced by the
By
API
losing
down.
the state on the API.
Yes, and it's not.
It's not, no.
The calls stay up, but you take actions later on those. You have issues with
I think it would work apparently. So, because think of the inputs, right? It's just a call entry, leg, and the destination. So the call is still on OpenSIPS. We've just restarted the API. So the transfer should work, no problems.
Okay.
Maybe what you would only do by doing this is the subscriptions. So you would OpenSIPS would just send all of its events to this dangling UDP port that no longer exists since the API restarted, right? So it no longer resubscribes. So that is all the negative.
It does not resubscribe, but the subscription is still there. So as long as you restart the API on the very same ports, we will basically.
No, it doesn't. The notification for is ephemeral. The
Somehow stable or controllable, we might be able to. I mean, yes, doesn't take that much.
Yeah.
Bottom line, the worst case is you basically lose the events.
Yeah,
That's
look
it.
at this one, for example. It's subscribe port 60 to 43. So that's ephemeral. Yeah. Once you restart the API, you lose that. OpenSIPS for a while it sent these, hey, I don't know, call hold happened or a buy happened. Yeah, to some port that's no longer even listed on. But it's all good.
This happens in
Yeah.
most scenarios anyways.
Thank you. Let's have some round of applause for you. Next, we have Ruslan Krajna, also from the OpenSIPS project. And
I prepared here a small
directory with some resources. Now, what do we have here? In the workshop directory, which is actually the equivalent of a test set, I've written two tests. One is for a call registration, and one is for placing the call. Let's see what we have in each of them. Let's start with the registration. So this is what that is actually running the registration. We'll also use a and grep an grep instance so we can follow what's happening. But I will show you afterwards other ways of troubleshooting this post-run. Right. So here, let's see our scenario. Right. What do we have here? So for this scenario, in order to run a registration, we will need, of course, OpenSIPS, which is defined here, and localhost, and we were saying the port is 5080 with the default 5060. As you can see, everything will be run on the localhost network, so we're not declaring a separate network, although we could have done that, but we haven't done it just for simplicity. If you want, we can do it together. Next, what we are saying is that in order, if you remember on Tuesday, I said that the tasks within a test set are run in parallel. So if we would have just written this, it would not work. That's because while OpenSIPS was trying to boot, because this task will be starting parallel. So this means that while OpenSIPS would start to boot, the UAC would set the register, but OpenSIPS is not up yet, so probably not work. But let's see. Let's run it like this, shall we? Well, it's a demo. Why not? Okay. The way to run it is cipcert, and the test set we want to add, we want to execute. I showed you earlier that we have two different tests, so I will also only want to run the 0.1. I'm filtering with --test, so I'm filtering what is being run. Okay, let's see what happened. Oh, okay. Oops. So we sent a register from localhost 5080 to localhost 5060. The register was successful. This means that OpenSIPS boot quick enough that CPP found it live. There was a question from Flavia.
Where did you insert the XML scenario?
Where or why?
Where?
Okay, that's a very good question. The answer is nowhere because I didn't have to. That's because if we go here on the documentation, we would see that, where is it? Config file. If missing and no CPP XML file is in the scenario directory, the UAC default scenario is run. So basically, the cpp.xml is the default file searched by this task. We would see on the calling run a UAC, then run on UAS. We will see that we'll have to be explicit about which files CP should use.
So it can be things.
Yes, can be anything. At this point, we just use the default. Just use the default file. If we wouldn't have had that, you know that CP itself has a UAC mode, has an internal UAC XML that would have been used if we didn't have the CPP XML. Again, we were lucky this time. The correct way of doing it is to add a dependency set that says, well, don't just run CP, wait for OpenSIPS to be started, and wait half of a second before, so it can properly initialize. Yeah, that's as simple as it gets for registering. We probably should, I mean, you probably know CP, we don't need to look into CP XML or into OpenSIPS CFG, this is completely different. I told you OpenSIPS CFG is exactly the default scenario. But let's take a look at the code side. So here, things are a bit more complex. We're still using the default configuration file, so we don't need, it's basically the same file. We also have the scenario which describes what entities are involved, but also a couple of other configuration files that we need. For example, the configuration, the OpenSIPS CFG, SIP-P, it's basically the same as earlier. It just runs a registration XML file, but we also have a UAC, user agent client, which basically will act as the two endpoints for a call. Both of them are actually referencing this media pickup in order to generate media, so we can have media for this scenario as well. Let's take a look at the scenario. So the first is basically the same. We can, besides using a different username, which is calling, it's more or less the same. I can actually do a diff for you, right? It's essentially the same, line by line. This is the username is the only one changed. But then, once we start OpenSIPS, we also need we need a user agent server that is able to receive the call. So as you can see, we are using the same port for that. That's because the very same port we registered, right? So we need to use the same IP and port. Notice here the configuration file is the UAS. So here we are explicit about it, Flavio. So this is how you pass it. So we're saying just use this XML file and just make sure you start it after the register was started.
Since always just one.
You can send, there's a count. You can send how many, but default is, yeah, there should be, oh, it's not. Oh yeah, that's because I think it's a more generic from CP. So this is, yeah, it was not called count is calls. So this is the more generic task of CP. But it inherits all UAC and UAS inherit all these settings from the generic. So there, it's actually, as Python is it's a oriented programming language. It benefits of all these features, and we will see later how that works. Actually, I see a bug here. I just figured it out. So after we register here, we said require the register tasks or wait 0.5 seconds after the register task was started. That's not registered. That means we should use a different dependency, right? Not started, but it's after, I think. Right? So these dependencies say exactly when to start this task, and we're not interested to start it after, but rather after it finished, right? Because only after it finished we know that the user was actually registered. Of course, this half of second time, which gives us like more or less, I mean, registration shouldn't take more than 0.5 seconds, but still, this is important. So now, after we started the registration, we can actually place the call. And yeah, we're using the proxy saying, well, this is, you should be using this proxy. There's also a proxy port. If you actually could have used the port here, 5060. Or not. This is actually the proxy. We know OpenSIPS is listening on this IP. This is the duration of the call. For example, we want the call to last 5 seconds and should be started after, again, we can start it after register was started, or more precise, after UAS was started, just because we know the user agent server needs to be started so we can place the call. Yeah, let's run it.
Just a quick question, why cannot you have that registration task to give you like some signal that is actually registered? Why do you need to rely on like time?
So the question is, why can't we have the registration task somehow tell us that it has been registered and we rely on the time? In normal circumstances, we should not rely on time because time differs between different testing environments and stuff like that. So it might be dependent on that. This is just for, I would say, simplicity for now. But again, here, for example, in this scenario, we don't really, to start the registration process, we would need somehow OpenSIPS to tell us exactly that it had finished and it had...
Well, you can send like options, for example.
Yeah, but can you like run in this scenario, like you will dump my MI and check if that register actually worked only then?
Correct. That's something. Yes. So of course, another thing that you would do is run a scenario, run a different task that will check whether the registration is there or not. We haven't done that, but yeah, in normal circumstances you could even write a process that would or execute a code that would actually wait for or execute like polling OpenSIPS and see if the registration.
No, fair enough.
You can write your own that listens for an event from OpenSIPS and wait for the registration event to happen and then finish. But you will still need to let's say to add a dependency on that task, right? That's a very good idea. For example, this required for a dependency to be able to run a script that says whether the dependency is satisfied or not. And in that script, you would have gone and say, hey, is it registered? Is it registered? And once it's registered, exit, and that's when you're allowed to run. This is a very, very good idea that I'm going to develop next. Thank you. Let's see, we ran our test. So here, this is the initial register. This is the second register. As you can see, for the first one, we are registering from Summit. The second one, we're registering from colleague. Do note that for every task execution, let's say here, we are using a completely different snapshot. So for every task, for every scenario, we containers that are needed. But at the end of it, we will terminate all of them. This means that for every task, we will start with a fresh instance, right? We are not inheriting anything between different tasks. This is a very actually, we might inherit something. There are these initial tasks and cleanup tasks that can be provisioned at the test set level. So those are available throughout the entire test set run. So once we start the test set, we run the initial tasks, we execute all the tasks, and then run some cleanups. But in general, you must think like not a black box, like a gel for every task, right? You create an environment for every task, and once the task is created, is executed, it is afterwards removed. And now here we have the call. As you can see, we're using different UAC and LOC. So we're setting for every CP, we're setting the proxy key. Here, right? Imagine, so now we're not running on localhost, but what if we would have run on a different network, let's say, on my local laptop network? What if I would move somewhere else? So it would be nice if we could somehow easily change the network that we are running on, right? And this can be easily done using templating. So basically, each of these scenarios are actually template files that we can set it to 127001. At this point, we will be able to run something like this. Let's see. Copy this, put it everywhere. Copy this. Okay, so I declared 3 variables: the SIP proxy, the SIP UAS port, and SIP UAC port. Let's run our entire. Okay, not parse. Why is that? Is it called something? It's not called a class. Just a second. Picking up. Oh, I did not save it. Okay, sorry about that. I did not create that file. And we should see that it works as expected. All right, now let's see. So we defined this. As I said earlier, we might want to run on a different network, and let's see how we can do that. My network, my IP is 192.168.88.234. Let's use this one, right? Instead of localhost, let's run on this one. I will tell you from now it's not going to work. I know why, but I just want you to tell me why. I changed all the IPs. We're no longer sending from localhost 5080 to localhost 5060. We're sending to localhost 5080. We're sending from my own station IP, so it's not localhost. As you can see, both have timed out. Let's see why. Let's do some troubleshooting now. For each run, you will notice that we will have a logs directory. Let's see what we have in here. We have every run that we executed. This is the timestamp that we executed that instance. And for simplicity, we always point the latest link to the latest run. So let's see latest, logs latest. Here we have the controller logs, which basically it logs what container is started and all sorts of information about the internals of the test, so not essentially how what the test did, but how they were started, dependencies and stuff like that. We're not interested into that. We're interested into workshop, let's say the first one, registration. Let's see the registration status. It's 0, so this means that registration was okay. However, if we take a look at the logs, and we also notice that in the pcap, we're not getting a 200 OK. See, so the last, this is the last file, the bottom of the file, we did not get a 200 OK. Let's check OpenSIPS log. Okay, we have a couple of words. As you can see here, there's nothing logged as if OpenSIPS had received something. And I know from push SIPSert service. And we can do that, let's see. So here we have the OpenSIPS documentation. We can do that using the socket configuration, right? So instead of hard coding in the configuration file, the socket OpenSIPS is listening. Why not just saying the socket is UDP column, and we'll use the default OpenSIPS. There we go. This means that we are providing the listening interface from the itself, so we don't need to hard code that in the OpenSIPS configuration. Let's run this and see how if it works properly. For pass, we have a call. As you can see, OpenSIPS forwarded, and it's all good, right? Same, we have flowing between the two. There's another thing that I would like to point to show you. The fact that we are, so for every OpenSIPS instance, we would have to force this socket. Moreover, for each SIP task, we will have to provide proxy, IP, and port. Right? As you can see, this is duplicated. However, there's a way to simplify that. What if we have, I will open another file and say, okay. What if there is a way in SIPSert to provide or tune the default values for some of the, for the task. So for example, we have the defaults node, and here we have actually it's not like that. Here it receives the default node. Let's say it receives the type of its settings. For example, here for OpenSIPS, we want to provide the socket. Oops. Socket is always this one. This means we don't have to provide it here for each OpenSIPS. Let's give it a shot, right? Yeah. Works, it's expected, right? It takes a bit longer because it's a code that takes 5 seconds, but it still works. Yeah, let's go a bit further and modify this for UAC CP. So we have the proxy, which is always proxy. The IP, which is always the SIG proxy. And the port. Have the UAS. So this allows us to remove this. These files, essentially simplifying or keeping only as much information in the scenario as possible. Let's shot. So it's still working. Everything, our changes were flawless. Oops, something went wrong. Let's see where we. Yes. There's some sort of error. Report everything. So here we're registering from the UAS port and we're calling to the UAC port. Let's see. Calling should be registering from 5080, not 5070. That's the problem, but I'm not sure. Someone messes the ports here. Or I mess up the ports. Debugging. This one is working. Okay. Yes. Oh, yeah, that's why. Yeah, I get it. We need to force use it. I did not spend too much time refining this because I wanted to do it together so that you get the
That's useful. Well, just a quick remark. I think with RTP proxy you might not need to wait because we have special features. So basically, main process would not quit until everything is ready. So essentially, whenever the main process exits, we guarantee that
I see.
like everything is up and running. So
That's not.
well, maybe it won't work, but we'll see.
We can always add it. I mean, it's just testing, right? It's just development. It's just.
Yeah, but you removed from OpenSIPS too.
Yeah, you removed it.
No, OpenSIPS. The second task you removed from OpenSIPS the weight from OpenSIPS as well.
Yeah, but it's fine. I mean, we will start them in parallel. Let's see. If it doesn't work, we'll just add a small timer. It's not that bad.
But there is dependency. So RTP proxy needs to start first, so you still need to wait.
Yeah, that's true. Oh, you're just saying we just need.
Yeah, OpenSIPS needs to wait until RTP proxy.
Yeah, we don't need to wait for it.
Yeah.
That's true. I believe it's ARMS. Let me double check. Yeah, ARMS. So here you can pass an optional the optional arguments that are being sent to the RTP proxy. So in order to operate it, we will need to add -s. I think it's UDP 2 and -l. I believe if we do it like this, it will listen on all the interfaces, right?
Yeah.
And yeah, it should be working as. Unknown task type RTP proxy. Oh, okay, I know why. I haven't installed our change yet. There. let's see what it does. Then to create, unable to start.
I think you didn't put like the name of the command because it just tries to
Yeah, it tries to run
minus S.
right. But it should have taken the CMD command, right? This one, let's.
Maybe some problem with it.
It's probably because of that. Let's use the minus F. Oh,
No,
and
no,
also
no.
let's keep it in background, in front. Yeah,
But-
we need to keep it in front or foreground.
Ah, you sure? Ah, okay.
Yes, because
but,
that's-
But then you don't need the big F. Because it,
Yes.
big F.
Should not need it.
That's,
I think it's
open
working
six.
now. It's still not working. Let's see why.
No, big F definitely is something different. No, big F remove.
Didn't initialize. No, currently it's not able to initialize it, so I don't think it sees. Oh, it's SIP proxy here. My bad. I can feel it. It now timed out, and I know this is correct. It's okay, it timed out. Started the others, but nobody terminated the RTP proxy, right? So since there was a task still running, complete, and we will need to somehow tell the SIPSer that RTP proxy is actually a daemon. So once we finished all the other tasks that are not daemon, we should also gracefully terminate these ones as well.
Okay.
And we do that using here.
Oh, you have a flag for that. Ah, okay. But now it's not a daemon because you switched it to foreground.
But yes, it is. But let's see what happened. So it finished with 137.
No, we got the signal, so you send it a signal.
How do you gracefully terminate it though?
But what do you mean? Like right now you're running it in like foreground mode.
Yes.
So it basically sits on std, std in. So you terminate it by just closing like the pipe. Like,
Okay.
So you just close the socket if you run it in foreground, or you run it in back. Then you use the PID file to like send the signal.
The problem is, so imagine now we are running it as a container. That's why we need it in foreground, because it needs to be attached. So in order to finish it, we're using Docker style, which essentially.
But you just close the pipe.
I don't think there's a way of closing the file through Docker.
No, why? By Docker, you're just in your application that opens. Your scheduling application that does open the container. You have std out, std in.
Yes.
So you just close the socket. So you close your std out.
Yeah, I see.
So you in your Python code you close your.
Yes, I see.
You close std out, and then RTP proxy will
pick
just
it up and just terminate it.
yeah.
The problem is we're currently use Docker style, which essentially sends a SIG term to the application for it to finish.
Yeah, well, SIG term is okay, but you'll get just get this.
You'll get so we can
the
probably
code.
bear with us and for.
You'll just
for this
you
code.
just condition on that SIG term, whatever exit code it is.
Is there a graceful one?
SIG hub, I think yes. Yeah, we can. I think it's SIG hub.
We can look into that.
Yeah,
later.
SIG
We need
hub
a
I
way
think is
to-
more.
We need a way to modify the terminate RTP proxy. That means that probably all our tests will fail, but we will look at the pickup and see if they will work, and we will afterwards. Now that we have RTP proxy up and running, we need to modify OpenSIPS script to use it, right? So we do that, we modify OpenSIPS. Over the logs. We will be using the RTP relay module because it's simpler. See, and now it's RTP process. That's another problem that we need to solve. So here we need to hardcode RTP proxy IPM port. We can pass it from SIPs, and actually we can. If we make this a template, we could pass it using the templating engine. And now that we have everything set up, here when we just use RTP relay page using RTP proxy. Something is wrong. Looks like OpenSIPS did something. Let's see what. Hey, code was generated. That's so much fun.
What happened?
We got core down.
Oh!
So see, RTP proxy was properly and I think I know why we have this core down. We'll recreate the image. I need to modify this. Yeah, I'm leaving this so great. There was a bug in the SDP parsing, which I think we hit. Yep. Yeah, hopefully it will work.
But it means that everything works.
Yes.
So when your test fails, it tells you something.
Now let me give you a bit more. Remember we started this we started this Python file, and its purpose was to simplify as much as possible right. So here this allows us to say here the socket is UDP proxy. Or even, I don't know, let's say not socket, just set the IPM port. IP, which defaults to port, which default, the command should be RTP proxy minus F minus, actually this should be modified here in the document file. If we use the entry point.
But, yeah.
So we will drop this one as well, and if we don't need debugging, we can drop it all the way, right? We can drop this as well. Yeah, and basically what we have now, what we have done now, let's install this new version. We essentially modified whatever we had earlier into this simple configuration, just specifying the socket. Actually, we said it's going to be IP. they're not ready yet. But yeah, we don't have any more time, so. I think it didn't. Yeah, it didn't find the OpenSIPS because I removed it earlier. No, it's the proxy container didn't.
Maybe something else.
So I will write them here.
What does big F does?
Oh, sorry?
Not sure what the big F does. I'm curious. No, something is.
Something is wrong.
Oh,
So if I
oh,
just
we got
use
something in the light, and then it fails.
Oh yeah, it's the same. OpenSIPS did not compile, so it's still crashing. Okay, it's fine. Yeah, we have an OpenSIPS crash. We'll need to dig into. But besides that, I think we're good. Yeah, we got a reply. So that was my session. I hope you're trying to give it a shot in the next future.
I got a question like, why we're not having it as part of like, sorry, anyway, the question is why don't we have it as part of like normal OpenSIPS GitHub action run?
It is.
Ah, it is?
So it's already integrated as a GitHub action. The only problem is...
No, but it's not triggered. But
yes, that's because we didn't want to, because it takes like a lot of time to run all of them. So what we are planning to do is run it on a schedule every night. You can do that in GitHub Actions as well. So
why does it take?
It takes like 15 minutes per run.
15 minutes is nothing really.
Well, now. It might hours.
Yeah, but
it's just it hasn't been set up yet. So there is another project that has all the tests, which we can easily trigger. Because after we create we push the fix, we need to create a Docker image and then run all the tests. So there's a couple of other components that need to be. All of them have been properly automated since now. It's just we didn't put them together yet, but we're planning to do that in some one way or the other. There's another question for Vlad. Does this answer your question?
Yeah, well, I mean...
We can always discuss about this.
Yeah.
Can I test an external system?
Definitely. So instead of what we would have been... I'm going to write a blog about this. So if you would want to run an external, then you would no longer start RTP proxy in OpenSIPS because they are somewhere else, and simply the SIP proxy would be the proxy you would like to test. But remember, you will need to find some sort of ways of provisioning users, removing them, so that when we start the call, they will already be provisioned. So you'll have to run some other, let's say, task APIs and stuff like that to create the users and remove them afterwards.
A second question is, only SIP consider best if it runs the whole scenario or just the call?
That depends on CP configuration, because you can configure it exactly. It has some parameters that says if one call is successful, exit with 0. Because from SIPSer perspective, we're only questioning the exit code, right?
Mm-hmm.
So you can configure it in different modes. I'm pretty sure I checked that when.
I want to be sure that the by the ACK by only
yes,
the whole scenario.
That's true. You will find, definitely, if you don't receive a message, the scenario will fail. So we will detect that. But there are also other checks that you can do at CP level, and you can check our GitHub code with the OpenSIPS tests. You will see that, for example, we check whether ACK has the proper CSEC, whether the contact has the proper format in case of a topology hiding, and stuff like that. So you can fail even earlier the scenario, and that would basically fail the test and indicate to SIPSer that the test is not okay. So yeah, just check those or drop me a line and I can pinpoint you exactly where to look at. There are a couple of other questions, but unfortunately we're a bit behind the schedule, right? Or okay.
Can we run like multiple instances of OpenSIPS? So like if we had to run it through, I think like a proxy mode and a B2B UA and test the full scenario, is that?
Sure, definitely. Just make sure either IPs don't overlap, either ports don't overlap. Simply just open two instances with different configurations in different ports, and that's it.
What if we need like random port number? Is it possible right now?
No, it's not possible to. I mean,
give me like random port number. I want to use it like connect those
but
like three servers.
It's not something simple. Just need to add it.
And separate OpenSIPS configuration files as well.
Of course, yeah. But you that you will have, for example, here there's a config file. You can specify the configuration file that you actually want to use for each instance. Yeah. So Max, what you can do is instead of hardcoding the port, we can use the Python and Jinja functions. Python and Jinja have a lot of functions that can probably generate the port for you. So basically at the templating level, we can define something like, so here we RTP proxy port, say something like, I don't know, random, I don't know, random. I believe so. If not, we'll have to make it work. I think there was another question on the back of the room. I think probably should be the last one. We're a bit behind schedule, sorry. Yeah. Yeah, that is possible because so the question is if we have a different directory where we have a different config file or different file, you can actually mount different volumes in the container. So you can basically mount a different directory if you want to. Yes, it's just in the config you just say volumes. There's a volumes, and you can provide like several others, destination and where to mount them. Yep. All right, thank you very much, guys. Thanks for the questions. Thanks for your patience. Hopefully you will enjoy SIPSer as much as I do. Thank you. Thank you, everyone. Now, Bogdan, doesn't work. Okay. Now Bogdan is going to talk to you about a very nice and cool feature we've developed in OpenSIPS 3.4. I hope you will all enjoy it. Take it away, Bogdan.
Thank you. I will. They saw how much a person can cough during a presentation. I just said, okay, I want to be sure you have something to drink. Just in case, you never know. So, what I prepared for today is to show you how easy it is to build an external B2B logic with the new addition in OpenSIPS support for the agent endpoints. So I will start by going a bit through the slide, just to understand exactly what we are talking about, to understand exactly what's the setup we would be working on today. So, give me 1 second. Okay, so, well, sounds like one of these sales pitch, but we will see how you actually implement the most simple but functional back-to-back by writing only 10 lines of external script, in our case in Python. So using 10 lines in Python, how you can do B2B with OpenSIPS. I have here a couple of slides just from Tuesday, just to remind a bit what's the idea of this SIP user agent support. So basically the ability of OpenSIPS to expose a fully functional user agent client and user agent server support. Meaning OpenSIPS being able to act as an endpoint from SIP perspective, so not necessarily as a SIP proxy. And of course, okay, you are an endpoint. The question is, okay, what's on the other side if you are from SIP perspective endpoint? And the answer, yeah, on the other side it's the API. So we have basically this API-driven SIP user agent. So if we look at this functionality, we see OpenSIPS as a mixed back-to-back. On one side you have SIP, and on the other side you have API. So basically, the whole idea would be to have such multiple entities, user agent client, user agent servers, that we do control from outside and we logically bridge them as we want. You can build your own back-to-back. So such user agents, so SIP endpoints, may be created at the script level. So if you have an incoming call, incoming invite, of course it will hit your script, and then you say, yeah, okay, I want to actually transform this call in and to act for this call as an endpoint, so as a SIP user agent server, and then you pass the control to the B2B module in OpenSIPS. And from that point further, you can have an external application controlling how this user agent server will behave. Like, okay, what should be the reply to be sent, when to accept the call, when to terminate, if you want to do invites and so on. But from OpenSIPS script perspective, it's simple. You will see we have the invite, pass it to transform it into a SIP user agent server, and that's it, we are done with the script. The second option for creating a SIP user agent client, so when we want actually OpenSIPS to initiate a new call, we do that through from outside using an MI command. So if it's server, it comes from the script level. If it's a client, you have to start it, of course, from the outside. And doesn't matter how you start such a user agent session. After that, you can do the full thing, sending replies, in dialog requests like green light, and of course, at the end, at the end you can do the termination for the session. So yeah, those are again from Tuesday how the scenario for a user agent client is we have everything starts from the MI session, from the MI. You get the invite on the SIP side, and then replying you see whatever comes on the SIP side, it converts into an event on outside. So whatever happens on the signaling level, it's translated to an event or notification that may be consumed by any other application outside OpenSIPS. And in the same time, that application from outside OpenSIPS may trigger MI command in order to control what to happen with the call. Like in our case, here it's doing a reinvite after the call is established, and also the termination for the call. Again, these are generic, some generic information just to get a bit into the topic. And here is how a user agent server looks like, right? So we said everything starts with an incoming invite that will translate, doing some scripting into providing the session key to the application, and once the application has the key, it may decide further, okay, what to do. So the key is an identifier. So once the external application is aware that the session was, the user agent server session was created, doing MI commands, it may trigger, may control the whole session. And similar with events coming from the SIP side. So yeah, let's see the actual setup that we will have today. So actually how we build this 10 line of Python code external back-to-back. The idea is pretty simple. We have a caller and callee, so two SIP endpoints. And both are connected basically into OpenSIPS. One would be, okay, starting from there, we have the caller generating the call. Here we'll have internally a SIP user server. And then we create the user agent client to get the call out further to an actual callee. So we have the caller and callee talking one each other, but from SIP perspective, it's not proxying. So there are two completely different. From the OpenSIPS perspective, I have two user agent entities, the client and the server. But what's the logic between? So how the information and how these are correlated from the logic perspective will be dictated by an external application. In our case, this kind of Python script. Basically, what it will do will be like, okay, that's on the next slide, change. So you see, from the SIP server, it's pretty simple. It's just two lines of information. When the call comes from the caller, we do a user agent session server init. So we create a server entity, and then we do a raise event just to notify the application that this okay, a new call was received, and in our demo, what we will do, we will look up from that script, from the external Python script, we will do a user location, so basically to see where the call is registered, and send the call to it. So it's just basically a call between two endpoints. But the whole logic will reside outside in this Python script. OpenSIPS will be actually just a SIP stack having a user agent client and a user agent server. That's all it knows, nothing more. Everything else, it's outside. So basically, you decide exactly how you want to interconnect the two sessions, the client and the server session. So here, what we will do when a new server session will be created, through MI, we're going to run an UL show contact, so to see if the callee, so the target, is registered somewhere. We'll try to fetch this registration from within OpenSIPS. If we don't have any record, we will generate back into the server session an 404 not found. So we'll instruct OpenSIPS to send a 404 not found. If we do find one, okay, we keep the user agent session key. the new URI returned by this UL show context, so we change and we will we will start this time a client. So we are done with the server side, and then we will start basically the client side. So we will initiate a call towards the caller with this UA start session. So that will be the second session, using as destination whatever this UL show contact returned. So at this point, we will have the two keys, user agent server, user agent client. And from that point further, what I will need to do is just to keep a logical mapping between the two. So to correlate specific events and to have our logic. In our case, it's something simple. We just pass through the events from one side to another, but of course you can do whatever things. For example, generate from time to time some invites only on one side, or you want to disconnect one side and create another session and bridge with the other one, and so on. So you can individually handle the two sessions. That's the whole beauty here. Now, once let's say we have the user agent server and user agent client created, we will start getting notification. In the first place, we will get notification only from the user agent callee side. So basically, we will receive replies, and from the callee side, like okay, ringing, and eventually a 200 okay, and so on. So this will translate into receiving an event about early and answered, or of course, maybe rejected state if the colleague declined the call. And for these kind of sessions, we just simply pass through them on the server side. So we do UA session reply with whatever information received on the user agent server entity. So all notifications received from the client side will be passed through back into OpenSIPS via MI on the user agent server side. And in a simple case, okay, the call will end at some point, so it can be terminated maybe terminated by any of the endpoints, so by user agent server and user agent client. And you just need to correlate, so exactly to see, okay, if this termination event came from the user agent client, then okay, we need to generate a termination also on the, sorry, that was UAS here. So if it comes from client, we need to send it to the server. If it's coming from the server, we need to send it to the client. So just to be able to route it in both directions. So basically that's more or less the logic we want to have. So the idea, again, I receive a call, I do a user location, so I find where the call is registered, and I'm passing the call further by creating a new client entity to the endpoint. Whatever the client provides me in terms of replies, I'm passing them further on the other side, so towards the caller, and at the end, I'm just bridging the termination event between the two. So that's in terms of the logic that we want to have. If you have any questions before actually seeing how to do this, so if the scenario is, let's say, hopefully clear for you. Okay. So far so good. Now let's go back to the fun part. And to be easier, let me reconnect to a mirror on the screen so I can see the camera here. Right. So let's start with first increasing some fonts. Is it better? Should I try to increase even more? Yeah. Okay. And let's do the same with right. So that's exactly what you have to do in terms of OpenSIP's configuration in order to get this working. The setup is pretty simple. I will have on here on the laptop running on the loopback, so on 127.0.0.1 IP. OpenSIPs first, also two SIP clients acting as caller and callee. And what I have here, it's actually the standard, actually the default OpenSIPs file. And I'll just go through, okay, which are the changes I did there just to enable our scenario. And in terms of I need the B2B entities. So this B2B entities module is the one providing this support for your user agent, for the endpoints, for the SIP endpoints. And okay, I have some setting just to, okay, what would be the advertised content. It's not necessarily related to our scenario. That's the way the B2B entity works. It needs to know, okay, how to tells you how OpenSIP should identify from SIP's perspective when doing B2B entities. And what I also need is this event stream. Basically, that will be the way our application, the Python application, will connect to OpenSIPs. It will connect through MI and generate a subscription for an event. So basically, the external application will subscribe into OpenSIPs in order to receive a certain event. In our case, this way session. So the event stream would be the way OpenSIPs will pass back the events to the application. So that's what you in terms of scripting. Again, this is just the standard script, max forward, handling sequential. Anyhow, we will not have a sequential because we are not acting as a proxy, we are an endpoint. So once we start an user agent session through the B2B entity module, all the sequential requests will be automatically consumed by this B2B entity module. They will not land in your script. So basically, in the script, the only thing that we will see it will be the initial invite that we receive from the caller and passing it into transforming it into a user agent. But again, that's the default script we have it here, not a problem. Cancel processing, again, standard thing. We do, checking here, and going all the kind of standard part of the script. We have here, okay, we have an invite, an initial invite. And as I said, whatever invite is received by our OpenSIPs, I will create a user agent session server. So you see, I'm just creating it. In this variable, I will get the key. So basically, the identifier of the newly created session. These are some flags like getting replies, headers, some notifications. So basically, how verbose more or less this new session should be in terms of generating events and how much information I want to receive from that session. And that would be a good moment to raise a question. To raise a topic here about the media part. We mentioned that okay, we do a bridge in terms of signaling the two entities, but the question is, okay, what will happen with the media for the call? And the answer is simple: nothing. We do nothing about it. We will not get involved into the media part. We will let it go directly between the endpoints, and we will see in the Python just copy the SDP from one side to another side. So we will not, in our case, for this purpose, we will not touch it. We will let the two endpoints to directly negotiate, let's say, the SDP and then exchange the RTB. Of course, that's up to you. You may decide not to do that. Maybe you want the external application to modify the SDP, to control the codecs, maybe to use some relaying mechanism, whatever. So that's why you have the option to get the SDP in the external application if you want to, control also the part. So at this point, OpenSIPS will internally build the user agent server session. It will imply basically no signaling, so it will just be an internal structure. It will not generate any reply, anything else, right? And from what I want to do is to, okay, right. So what I will do next is to generate this session event. Basically, after creating the session, I want to notify, so to trigger an event to notify the external application that, hey, I have a new server up and running now, a new user agent server running. So that's the purpose of doing this raise event here. And that's the name of the event. And I have here, okay, some kind of attributes and values to be passed together with the name of the event. And I have here all the attributes, so they are paired like two, at the name of the key and the value of the key. So first, I'm just sending the actual key of the session, so the one returned from the user agent server. So I have passing the key, saying it's with the user agent server entity, the event type. Again, these are just parameters of the event. Saying, okay, it's a new one. I'm passing the current request URI, and also you see I'm passing also the body, the SDP. So that will be the actual value from the incoming invite. So I need to pass some information from this invite to allow the external application to do its magic. In our case, again, we have the key, the fact that it's a new incoming user agent server entity, the whatever request URI we have, and then the SDP. And more or less, that's it in terms of scripting that we have to do. So capture invite, construct the user agent session server, notify the external application with some information about it, and then all the control passed to the external application. From the script perspective, I will do nothing for the calling side. Of course, my script goes on because I need to handle registrations, just for the purpose of the demo, to allow the two endpoints to register into, so to handle the register request. But again, all the calling will happen here. And once the user agent server or user agent client are created into OpenSIPS, again, all the requests will not be related to these two entities, will not be visible at the script level. Will be automatically intercepted and consumed by this B2B entities module. So don't expect to see anything at the script level, just that initial invite. starting. And now let's take a look at the Python script. So basically, let's see how we bridge all this logic. So let's increase this one to 2. So we have here some how to say helper part, which is not necessarily related to to the actual logic. You see, I did a trick in order to help me with sending mi commands into OpenSIPS. Let me scroll up. I have this import here, CLI from OpenSIPS CLI. So basically, OpenSIPS CLI exposes a library that can be used by other Python applications. For example, if you want to simply send mi commands in a very easy way. So in order not to bother too much about how to interact with OpenSIPS through mi, I'm simply importing this OpenSIPS CLI library. Going back. So what the script will do? Okay, have a new CLI instance, and the first thing I'm sending an mi command, an event subscribe. So basically, my script wants to receive all the UA session events from OpenSIPS. So it will go to OpenSIPS and will say, okay, send me back all the events you have about the EU sessions, right? So that's the name of the session. So it's a subscription for the event. Basically, this hosted port, okay, there's some TCP parameters, not really relevant, but this they will be used in order to receive from OpenSIPS the actual notifications, right? So once I do subscribe, I'm reading the events to this host port socket. It is a TCP1. So doing binding, listening, and at the end of the day here, I'm just doing the receive. So that's standard Python stuff, just to be able to receive some data through a TCP connection. Nothing, let's say, particular to necessarily to OpenSIPS. But from what we care about, the relevant part is here. We have this cycling, which read events generated from OpenSIPS. These events are in JSON format from OpenSIPS, so we parse them as JSON to be easier to work with. And once I have an event received from OpenSIPS, I'm just calling this event handler where actually I put my logic. So that's more like not really interesting part, just to help me receiving the events. The whole logic that we care about implementing the actual back-to-back resides in this event handler, which will check what events were received from OpenSIPS and tell, okay, what to do next. So let's see what this function does. Okay, so this is the event handler. My idea was not to teach you exactly how to program in Python. Actually, I do suck big time about programming in Python. I don't like it, but that was the easiest way to do it here. Yeah, just to keep things simpler from this perspective, our logic here, actually our implementation here supports only one call at a time. So we have like this global parameters for UAC and UAC and US So one server and one client at a time. Normally, of course, if you want, you can do like a hash with keeping multiple correlated, okay, like pairs of clients and servers. But again, my idea was not necessarily to teach you how to do Python programming, but just to show you how you know, the events and the MI commands will link together. So okay, what we need to do is to check the information from the received event. That in params we have the actual JSON structure with the information from the event. So we check exactly what kind of what kind of an action we have in the event. So first of all, I'm handling the event type new, which was raised, if you remember. So, you see it here, this new event type new. So basically, that will cover the case when the event is triggered from here, from the script. So this event type new, I just received a brand new information, a notification about having a new user agent server created in OpenSIPS. And as I said, the first thing I do, I'm running an MI command back into OpenSIPS, a UL show. So I want to see if the caller, if the callee is actually registered. So I do here a bit of a magic. The information is in the request URI parameter, so that's what I filled in. So you see that correlation we have with the request URI, it's actually the real SIP request URI. I get it now here, this. I just need to strip out the SIP prefix from that request URI in order to do the lookup location. I mean, for the lookup, I need to pass an address of record, which is just username and domain, so without the zip column in front. So I'm just getting rid of it, and I'm checking, see, if basically the request URI is registered or not. If this UL show contact returns nothing, means my callee is not registered. So what I do this UA session reply. So I'm replying back to the session. So it is the same session which I received information about. So I'm pushing back to the session. 404 reason not found. So I'm not doing anything further with the call, I'm just ending the server session. If we are lucky and the callee is registered, right, what I will do, I will, from the registration, I will take the contact, so the actual destination of the callee. So that's the registered contact of the callee. And that would be the new request URI for starting a new session, user agent client session. So basically I'm saying, okay, I want to start a client session pointing to the contact, to the registered contact of the received request URI. Pointing to the new URI learned by the UL show contact. The same to header, the from here, I put something dummy. It's up to you how you want to correlate in terms of, okay, who's the caller. Here I just put, okay, let's have Batman doing the call. And in terms of, you see the body, the SDP actually, I'm just copying the one received from the original parameter. So I'm taking the SDP from the caller and I'm passing it further to the callee. So I don't want to get into the media. But again, if you want, you can play with it, do whatever you want. You can send another SDP not a problem. But here we want to be transparent from the media perspective. And yeah, more or less that's the way at least to do the original bridging between the client and the server. Of course, an important thing in this section, so when we do the bridging, is to remember the keys of the client and the server side, because we need to work with them further. So you see here, the original key, so the one received from the receive session, I'm keeping it as a user agent server variable, and as a returning for this UA session start. So when I start the client session, I'm storing the key in that UAC variable. So I have the server and the client variables, which are global, stored. So from that point further, I know which is the client and the server. That's why I said this is a very simplified version, because we have only one server, one client. That's it. But normally, if you want to support multiple concurrent calls, you should do kind of a hash map, whatever. And from this point, things are quite simple. If I receive event type early, meaning translating into receiving a 180, this will be automatically generated by the B2B entity, so I don't have to do anything special in the script. So whenever the session receives a reply, in this case on 180, I will get an early type, or rejected, it would be a negative, or an answer if the session will be received. Let me scroll it up to see so we can see that better. So again, early, rejected, answered. These are event types which are mapped on receiving replies. Now we do receive replies only because of the user agent client session, right? So only the client session receives replies. We send the invite, and of course we will receive back replies. So we don't need to check exactly which session generated the early rejected and answered, because definitely the server one cannot generate something like that. So only the client one. Now, if you want to improve the script to check things, of course, you can also check which was the session generating this kind of event. But again, for simplicity reasons, whenever we receive early reject answered from the client side, we pass this back to the server side. So you see, I'm doing the UA session reply. All the time I'm passing that to the server side, and I'm just copy whatever the code, the status was received from the client side. Of course, you have the liberty to change also the code, and we have the reason. So the two options. In our case, we just keep them as they are. We just want to pass the 180 eventual rejection and then the answer of acceptance. So up to this point, we are able to have the call set up. So we have the initial bridging, and then we are passing all the replies between the two entities. Mind like a really, you can hang up both client and server this time. Checking, okay, which is the originating session. So if I have the server, UA server entity generating a terminate on the other one, the client, right? Otherwise, I'm doing on the server. So if I receive termination from client, vice versa, to the application is the one which will decide. Try to actually call Alice. Can do an answer. So right now, the two devices are connected. If we look here, we have we can actually see the events the application, the Python application received. First is the new one when the invite was received, and you see after that we had the ringing, the received and the answered so early, and then the answered, so the ringing, the answered, and here we also have the SDP received the event, and then we just pass it on the other side. So we had this logic here for the answered, with passing the body from the, so I take the body from the 200 OK and pass it from the client side and pass it to the server side. And okay, let's put some space in here. And now I can do like hang up, right? So call terminated. And I just see here that my application, the Python part, received this terminate, which was okay, translated terminating on the other side. If you want, we can quickly do an SN grep just to see exactly how the call looks like in terms of signaling, right? So let's give again the call. Okay, just to this time let's make up from the other side. And yeah, you see we have two invites, sorry, two calls. So that's the first call is the one from Zoiper, and from Zoiper it's talking only to OpenSIPS. So that's what SN grep says. So that's OpenSIPS is an endpoint, right? There is no proxy further. So regular invite trying 180, 200, okay, and the buy at the end. So again, from a caller, from the Zoiper perspective, it's just talking to OpenSIPS. And then we have the second, the one with the Batman, right? It's easy to identify here. We have the caller Batman. And we have OpenSIPS talking, in this case, with the link phone. So it's a completely separate call, right? But again, we correlate them based on the events through the Python. The easiest way to show you all this is by doing this kind of a transparent proxy in between. But of course, you can do whatever logic over there to decide, okay, what kind of a reply you want to do, or how to connect, disconnect, if you want to keep one entity and to replace the other one, so you have total control over that. Let me know if you have any questions for me. Okay.
The way you have it.
1 second. Okay, we need to charge the microphone. So,
the way you have it set up now, if your Python script is not running, will the call complete?
No. If I stop the Python script, OpenSIPS will create, because that's what the OpenSIPS script says. It will create the user agent server session, and nothing will happen because there is nobody to control that session. Relies on some, in our case, we rely on an external entity to control the session. So it will just create it, and it will see timeout after a while because of the internal transaction. But there will be basically no calling, just a hanging user agent server. Because we lack, let's say, the brain to tell, okay, what to do next. So in this case, OpenSIPS by itself will do nothing. All the logic is outside.
How would you feel redundancy then?
Sorry?
How would you feel some kind of redundancy that service not running?
You can have, let's say, multiple applications actually listening and consuming these kind of events from OpenShift. So we can imagine different kind of ways to do it, right?
If you wanted to, say, like play hold music from a media server and then send out also to the colleagues, would that kind of involve two different scenarios?
The whole logic would become more complex. You'll have the user agent server entity, constant during the call, and you will create first a client going to the media server, and when you get the disconnect event, so let's say the media player did the playback and then hangs up, right? So when you get the terminate from the user agent client side, then you can simply create another, instead of hanging up, passing the hang up, you can create another user agent client session going to another destination, right? So it's just playing with client and server entities and to put them together as you want. Yeah, it's just about learning how to program in Python. Again, that was just an example. You can do in whatever you want. It's an external application. That's it. Doesn't matter what language is. Good.
Let's say from that external application, after the concept is done, I want to be in media. For whatever reason, I want to be in media. Basically, I want to pass on the history to another entity and send the information to that server.
Yeah, so as we have it in this example, basically, an application doesn't receive the with the endpoints, right? Let's say if you want to receive the media in order to create a fork of it in a different probably mangled is based on my so basically what OpenSIPS does when insert an proxy, right? But you can do it instead of doing it from the OpenSIPS script from your external application. So just change the SDK in order to control where the yeah. You can even do that. You can talk directly with the RTP proxy from, in case, Python script. It's perfectly possible. Yeah. As time is, of course, you speak the same protocol. So if you implement the protocol for the RTP proxy from your application, yeah, you can control this media relay or whatever from your script, from the Python part. Okay. Other questions? Or no, I mean, it's simple. We can share it just for the sake of the demo. But the most important working with the MI commands, we are using that CLI library, which is on basically it's the same code which is used when you do the OpenShift CLI applications. To reinvent. Okay, so yeah, thank you. We are done for the first part of the day with the demos. Now is the lunchtime. Yeah, so same place as before. Enjoy lunch. In 1 hour, be back. Okay?
I have like some. Yeah. I only use Python a little bit to parse JSON flip tokens. That's about it.
We need to charge this one too. We need to charge this one too. I think so. To take advantage of the breakdown for 1 hour to put it on charge to charge. Question is where? I don't know.
I like that API thing on it here. I like that last presentation you did. I like that framework.
Yeah, that's
how much, how mature, or how much have you done with that?
That's something completely new for 3.4. So I would say that okay, it works, you know. But we'll start actually doing real work, then probably we'll figure out okay, maybe some different features are missing or some exception maybe needed and so on and so on.
Yeah.
Right now the whole implementation was more or less based on the idea like actually it started from the need of injecting an RTP stream, but with from an engine which has no SIP capability. So you just have an RTP stream coming from somewhere that you have to send to a user agent, to a SIP device.
Right.
So you have to come with the SIP layer on top.
Okay.
So in that case you have only one.
So you have the SDP. You just need to.
Yeah. You have the RTP. Yeah. Like you put it into an SDP, like describe it into an SDP, and then you send it to somewhere.
Okay.
Yeah. There was a project where it's a very weird case. Was a playback for trains.
Okay.
They had the generator for the GPR. All the devices inside the train were actually SIP based.
Yeah.
So they were looking for the idea. Okay, how we can take
your headset?
RTP stream and convert it actually to a SIP call.
Can you hear it?
So okay, let's do the SIP.
Where's the charger for your headset?
That's wow.
I mean, I was surprised they would keep the SIP.
Wow. That's how that works.
Okay, and back here. It's on the left, you said? I don't see that. No, I don't see it. Okay, I'm on the floor in the back here, yeah. Yep, I see that. I see it, yep. I got it. Thank you. All right, man. Chin, time to eat something.
It's like a feeling of human being trying to
Yeah. So by the end you'll be
fully
man.
recovered. They let me keep the room for no charge. Yeah. I went down there, I was like, uh,
Este baile lo tenía por los ¿Este no es el que teníamos los tres?
Es el jugo, los shooters. Este no lo tenían. Alguien. Chécalo en el runner, el río.
No, aquí no está. Esto debe haber sido prepa.
Sí. Esto lo debe haber tenido Luis. Luis 6.
¿Y dónde está él?
Ya se fue, no te dijo adiós.
No.
Y te dijo adiós en el tren. Pero este es el café que pudiste refrescar.
Este tenía tres y yo nomás me dieron café solo.
Por eso, nomás lo querían refrescar.
¿No? Yo ni sabía que cambiar.
Pues este era el café que iban a refrescar. No viniste a ver en cuarta. Ah, por eso.
Porque supuestamente nadie lo ha tenido. Esto es un breva que quedó. Y él nunca dijo que acá había cosas. Ahorita es que me sorprendí. Y hasta me dijo que hacía la mesa.
No, pero es que no. Yo fui a la mañana y no. Vete a ver el río. El río. Te va a dar río. Te va a decir que no.
Yo tengo el 11 allá en Pérez, que no lo he sacado. Date una manito aquí vieja para montar esto.
Okay, this is easier than typing back and forth with you. Okay, so Josh is having fun with the way it sounds. Yeah, but that's what Tyler was pushing on us. You know what I mean? So, yeah. You should ask this, and this is probably better. Sure, we don't got a report out there. Okay. If you're on call with VMware, would be and if do this and this and this, then why did they not?
Yeah.
Did they not want to do that, or did they not listen, or did? I'm just not what you know. Yeah, but I'm also fast. I'm not you can ever. I don't see, you know what, I hate to say it, I don't see how, sorry. Yeah, you know, what, I don't mind it. I understand that, but what, yeah, but, no, yeah. Yeah, here's the, what we probably need to go, we're probably going to need to get to is to a point where Dan is a yes no guy on what we're doing. I think that's what's probably going to have to happen. Because I think if we get to that point, then it will be a lot more palatable for everybody. And I think that, and that if Dan's going to be involved, because, you know, they're too afraid of Dan. I know, but the problem is Dan is, Dan's going to have to lose the yes no authority, or, you know, because, but and you don't think we've had that discussion, you don't think, I think, the problem is, you know, the other part of it is these are crises, or sort of crises. So, and so that's the other part about it is I don't want to spur a lot of cycles solving their problem worked out to their stuff because I got my own shit to get done. I don't, yeah. especially, I'll just say, like, for example, Splunk. Splunk is like, damn, it's very similar to Elastic, what it is, but it's a different tool, and it's a commercial tool, it's an expensive tool. And no, I don't mean, I'm saying it's expensive. It's not expensive. It's expensive. It's okay. Well, let's put it this way. For Splunk, there is no reason we're using Splunk for New York City. That's this comes back to you've got the wrong person making the estimations. I get it. I know, I get it. I get it, but that doesn't mean it has to trickle down to our stuff. So we'll keep this conversation, but I'm not. Yeah, it's time. Look at when you get this year's Robux catalog, and you set up that and that and that and that and that, right? You cut it out and then probably try to be on your Christmas stuff. Yeah. That's what they need. And then, yeah, no, besides that, across a lot of IT, yeah, you did. And, it's like, oh, I need this mother honey to go, to the 7-Eleven down the street to get milk, And so, sorry. As it, I mean, you never get fired for buying an IBM, or you can find the time to shoot for the stars, if somebody will say, why did you use a better tool? That was 10 times the cost. Well, worth it, I get that. But it just comes down to which isn't a problem. I mean, oh well. Okay. Okay. But don't realize that state hunter wasn't an RCM requirement. Dan opened his mouth and said, well, we'll apply to it. No, Dan offered it up. Dan offered up that Motorola will do this, and that's what, and so he got a. He wants to build the solution that is, and so. You're bringing it up. Oh, that's like I said. No, we'll have to have. This will be very interesting. So what's Josh's? Was Josh calling the meeting, or was he? Yeah. He's probably not gonna be very. Yeah, but I get it. Yeah. No, the reason I was thinking yellow was on there was just because he is probably the level was 10 of the bunch. But yeah, but if you go, but Pappas, no, Pappas. No, Pappas even will go further off the deep end. Yeah. Fuck, this is gonna suck. Okay. Yeah, Josh knows that we're like oil. We're like gasoline and fire. So. Well, I think we so we'll have to, you know, it'll be, this'll be. Well, we can see, I will see how this, we'll have to look, we'll just have to. You know, it'll be what it'll be, I mean, they've got issues, I don't know how. They just, we'll just, but I mean, it's gonna be, we're gonna sort it out. Yeah. And he, yeah, I guess the question, I guess here's the other question. What are the other problems that are, maybe I'll ask this. What are the other problems that they have that they're not messing up to yet? I mean, I'll just, you know, is that the thing? I mean, or, oh, honestly, I mean, to some extent, it's kind of a fair question. You know, if this other tech, you know, that could respond to it, right now, let's make it clear. And I think, you know, a lot of, and I know most. You know, they turn around and get up at the level of intent. You know what they get into, he's gonna want to do, he's just gonna take, you know, I hate to say it, he's gonna probably want to take just cherry pluck about being into it, people go drop that. You know. I mean, I hate to say it, do you disagree on that? I mean, I think yeah, and that, and you know, that's like just, you know. No, I think it'd be very beneficial. But yeah, I know that. Okay. Yeah, no, we'll have to, I would do it earlier in the week because, or whenever, when I get back, let's see here, Tuesday, we'll be back on Tuesday, on holiday. So, yeah, I'll probably do it early in the week, to get this thing, because it's gonna get, this summer, until like middle of July, this summer's trash for me. So, you know, it's just, I don't know what's your summer like anyway.
Huh?
Donald, are the kids staying with you?
The microphone is teaching here.
Okay. Okay, I just didn't know what.
Travaille courant. C'est mieux de courant. Je vais t'en faire ça.
Ken, I'm sure you go after national. I'm in.
No. Stream. Wi-Fi.
So, yeah, I probably had a message to Josh, we could do it like Wednesday. Or I think Tuesday's gonna be a little shit show from the holidays.
To by broadcast.
I don't. I guess. I was just asking. Is there control about this? Sorry, I'm just. Okay. Okay. Oh, okay. Atlas just got back from. We'll see how this. We'll see how it goes. I mean, it's just it is what it is. So, but no, I think that's great. I mean, honestly, the PCAP server. Me and Jason have already talked about this, and it's besides the that has so that we got a solution we can deal with. I'll just say it's we're going to have to spend some time with some architecture, and so we got a path that we talked about. I saw the handwriting on the thing, they were strong. I been around long for that. The only thing is one thing I resisted doing was spinning up the BCD environment and solving this problem. I spin it, you know, yeah, that's the, yeah, because that would be, needed to.
No, we need to connect HDMI.
Everything I know about BCD, I will train, I went to, I've already seen on BCD.
There's big HDMI cables.
So I don't.
Yeah, where is the splitter? That's one of the splitter. Yeah, bring it. What?
And it has a
I should hope to do.
Yes, and plug the other ones into yours.
Exactly, into someone that will sit in it. No, actually, we need someone that will sit in here. No, we need to sit with your laptop here. Guys, you know my stuff.
Still podcasting, can you stop for a moment? So what is
you want the chair or the stand?
Yeah, because see, I think where this is going to go.
you're trying to set up your
That's why this is coming. This is
Why do you need it? HDMI here?
100%. Because I knew it was.
We need the.
Oh, the copy.
And then it wasn't able to get deferred or
Somebody needs to stay
other
here.
people, my Lori crew, because it was a gate. Now
Lorenzo, can you say something? Oh my God. Okay.
Actually, give me a shout.
Can you maybe, yeah, that's the deal. Have your mic, it's. All right. How many shots do you have? What's the listen taste like? How does that look? Next question, next question. Yeah, I saw you something like this.
Do you have any preferences?
Any strong preferences, Alex?
Mary had a little lamb.
Mary had a little lamb.
Yes. I did. That's a different. He's going to sing, not that. No. Lorenzo, how are you?
Very good, thank you.
How are you?
Community complaints about the bubble.
Community, don't worry. Buttons is staying right there. I know it's all, I know it's the conference and we are after lunch. Probably most of you are getting sleepy, so we are trying to, we thought about the way motivating you, we want to throw it back for more. So we're going to give you all scotch based on relevant questions. And then the panel and the people on the forum, if they are answering right, only if you guys approve, can also do something. So we're going to play a little ping pong over here. I know the subject is hard enough and complicated, and as someone said, the IMS, but we're going to try to show our IMS lab and really discussing about it, trying to answer you guys as much as we can on any questions that you have. Our goal is really to have like 3 hours of open discussion. With us, Lorenzo, say hello. Lorenzo is with us. Hello, virtually and physically. Virtually and digitally, but also in the spiritual way, Lorenzo is with us. So as I was saying, like OpenIMS project is a part of a joint venture between a lot of open source projects. Of course, one of the most important things of all are acquiring and Omil and Lorenzo guys that got into this challenge. And based on open source and being ready to deploy. So, as I was saying already yesterday in the panel, we was understanding that one of the most difficult things is really about the observation of all of it, and really about having the logs and seeing between all of those 40 microservices that I'm going to give you a headache about in the next 3 hours. But the challenge is really about observing those kind of stuff, and really seeing the log and seeing the correlations, and seeing how it's all playing together as one service for the client side that will manage about 40 different microservices. And that is where Lorenzo and his team jump in and really help us in this community effort. So first of all, thank you, Lorenzo, and all of your team for this really great effort. And looking forward to showing you stuff with. So generally, when we are speaking about the OpenIMS, we are talking about deployment of multiple of services. We will touch the main one of them. So, of course, everyone knows OpenSIPS. I don't need to introduce OpenSIPS or OpenSIPS Summit, but we want to introduce some new open source project that we are playing with, that giving us the ability to have those clubs and to really give the ability for people to have a low cost implementation of radio networks. Because one of the main challenge over start playing with those stuff is having the mobile operator started running for. So if we are talking about doing a lot of work with any SIP gateway, any media gateway, anything that we are discussing, the first point of view of making the first low word call is very low. So I remember like it used to be done in Astricon, we were both doing all drunk in the evening competition about who is getting into a diatom first and can really do it in 3 minutes. But it's a whole different game while we are talking about the mobile network. And one of our goals is really to have one component that connects it all together, that it's still not where we want it to be. We are still working about having easier implementation and easier place to do it. But the idea is that we can do a full mobile network operator running out of our end. Thanks a lot to this all great project called.
First question on the shot of black. Who heard of Open5JS? Vlad? Okay. What can you tell us about this project?
It's
the first 5G open source implementation using lots of and then written from scratch basically by one genius. I'm satisfied with your answer. Thank you.
Can you go on?
Yeah. I'm sorry for this.
No, I like this kind of introduction.
That's a question, give him a stop.
Exactly.
Oh.
For me? Ah, for you, yeah. So Open5JS is really a great open source that giving us almost like 9 or 10 different microservices, depending on which kind of network you are running. Actually, it's giving you the ability to run 4G and 5G network. It's actually the implementation of what we call in the GPP world of EPC, like this is the core of the 4 or 5G network, and giving you really the ability of running most of your needs to run data mobile network. There is some other project. There is, of course, SRS run that we are using to run the actual antenna, to run the radio, what's called radio-defined software. So we have those kinds of devices. We will talk about them shortly. But the idea, think about them as the Raspberry Pi of the world of the radio. So you can actually run your own radio station if you want, really, to be a cool and disturb give your neighbors ability to listen for your music, or really run a 4 or 5G network out of those devices. And we will look at it later, how does it look, but the idea is while we are hooking up those devices into our system, the SRS run actually provision the framework of this SDR, which giving us the ability to run the mobile operator. We will talk and demonstrate about it a little bit later. There is few manufacturers, anything that generally our project and our goal is to support as much as we want, but anything that support by default by SRS run, we support on it. There is a list of compatible hardware devices, from very expensive labs from dozens of thousands of dollars to those Chinese reverse engineers ones that we can buy in $800. But really, it's not like you can start it. If you want to start playing with it, you don't need to invest like around $1,000 to have the basic NOC or mini PC connected to this radio network. And so generally, we decide all of those. Of course, we are with the great help of OpenSIPS guys, and last one was eating a lot of shit and gave a lot of from himself in the last few weeks of giving us the full compatibility diameter the protocols and diameter request and response parsing for really doing everything we need. Part of the things that we are really trying to do, and the OpenSIPS guys doing as always in the best way that they can do for community-wise, they're trying to give you us doing all of the logic inside of the CFG, and not needed, like if we're looking at other complete projects that did some kind of those, most of the attributes and most of the stuff was being sitting inside of the CFG, inside of the binary. And then each attribute, each vendor that giving a new vendor attribute that you need to push or to receive, you will need to recompile and to have your own fork of the project. And the goal of OpenSIPS is not to be like that, but giving us as the implementers as the right that using the end user as from CFG right, or the perspective, giving us the ability to be very dynamic. And we will see it later on, but it's look a little bit messy. Some of you might need to drink an extra shot while going on all over those diameter attributes. Which reminds me, who heard of the project OpenSIPS? Okay.
Oh, come on, that's low, that's very low.
Lorenzo, I'm sorry that you are not here to drink with us.
Okay, thank you.
Who else?
Me?
You're drinking on each line.
No, you go get your own.
Audience now there's 1, 2, 3, 4, 5, 6. Very good.
Don't stop, keep going. The bartender is in operation.
So while we are occupying here by really important goals, can you try explain us a little bit on the part of the microservices and projects that are involved from the observation perspective of the OpenIMS project?
Sure. Can everybody hear me?
Yeah.
Yes. Nice. Hello, guys. All right. So there's a lot of moving parts here, as you will see during the workshop. So I guess we'll go in steps, but it's basically three components that we're going to be using the job. One, you already know it, it's going to be Homer. So Homer is going to take everything that's to do with our well-known packets. So anything that zip, RTCP statistics, head logs, or anything else that you already know and can send from OpenSIPS goes there, and that's nothing new. Then there's basically querying for everything else. So to understand this platform, infrastructure, how things talk to each other, how they correlate to each other, we're going to use a combination of logs, metrics, and later on also traces. Some of them are going to be, let's say, exposed by the elements themselves. Think of the OpenSIPS Prometheus metrics that you can, of course, scrape and make part of the picture. But a lot of these other components are not exposed. So for those, we're going to use not EFF. EFF, which I'll show you about. But so in this scope, we're going to be leveraging a little bit of everything. And then Grafana, of course, is the UI and the point of observability, the tool we're going to be using to look at all of this data that we're going to be collecting.
Lorenzo, you're still with us?
Yeah, he's there. So let's talk a little bit again about setting up the lab. So as we were trying to say in the last few weeks, we were trying to get everything together based on other Docker OpenFind.js project Giovanni was introducing yesterday, and trying to really get a simple Docker compose that with few lines you can run your own network. Of course, there is a lot of parameters and a lot of Satan sitting inside of the configuration in this repository. Generally, you can all see this repository. It's sitting in our voice center team, OpenSIPS IMS. And most of those folders are really like being with each microservices with its own configuration file. Of course, we are not holding all of those project source code. Most of it we are installing the official it as part of the build process that we will talk about in a few minutes. But generally, really, we're trying to build like some big lab that running almost 40 something. Now, what is the count? 40 different containers that really giving us the full scope of the mobile operators. So when we are looking on that, we can find the view on where the Docker build. Go to the, let's talk a little bit about the build process. By the way, any questions this side now from your side to us? Nothing? Good.
Everyone's still in awe.
Yeah, pretty much in shock.
Half of them are in awe, the other half is, are they really going to make it work?
It's working. We are trying everyone to drink enough, to not spoil the attention.
I get it.
We decided to work on this strategy.
You want the Docker compose?
Yeah, so generally, show the CLI first to the build, first for the build, go to the build. So again, we don't want, because it's something like those 40 different microservices, as I told you, most of them we are actually compiling inside of the compose, and we have their own Docker build running inside of those folders. So we will not waste everyone's time, but again, after getting into the folder, doing Docker git clone to our stuff, then generally we have like this build script that Tzachi was building. And generally what he's doing is running the OpenIMS test build for the basic over the Docker compose, and then running the different first the OpenFind.js, then the OpenSIPS himself, By the way, we are in a process. We were just discussing those with Razvan and Bogdan in the last few days to have a better community generic Docker image. So for those kind of installation, we will not need to compile OpenSIPS, so we will can have some kind of a public Docker image that can get by environment variables which modules to install, or even like the targz of the template for the etc OpenSIPS, so each one can really build his own, use the same OpenSIPS image, but use it for his own generic needs. So this is one of our goals also from the OpenSIPS community, and generally very specific from the OpenIMS deployment. We have the SRS LTE. By the way, the SRS LTE was the first name of SRS run, and then after 5G got out, and they understand, shit, we need to rename the name of the project. So they got the smart idea of calling it a generic name of SRS, the Radio Access Network, SRS run. So still in some places you will see the reference to SRS LTE and not SRS run. Also something that we need to clean the code. Generally, after building, after cloning our repository, running those 3 builds, you're supposed to be able to run the stuff. Of course, we are needed we are given some big amounts of parameters that you can set up over the env inside of the .env that you can see inside of the repository. If you are working with Docker, with the Dockerized environment that have different of external IPs, or you want, even if you want, let's say, to run few antennas that are running on different networks that need to, on the different hosts that need to have access. So you might need to change what is the address that you want to expose over your network activity. So there is, like, again, Docker host IP, for example, you need to change it to the host of the IP of your host network. So to make sure, if you want, actually, it's not mandatory if you're not using it for external services to communicate with it. But again, it's something for good practice to set up on the day one, so you can always get others. We try to go in most of the IPs configuration and everything being deployed already inside of those CNP. If it's not broken, don't touch it. If you have anything that need to change in there, of course, it is each one can do those changes. But especially for lab purposes, it's better all to work on the same environment and the same clusters config.
The idea really is that sometimes when we implement this on an existing network, so you have the basic stuff already in the env, and you can change or replace just the specific microservice you need over the env to a different one. And having all that with the installation coming with all the networks, all the LAN, all the VLANs, all the Docker network port forwarding, and all those setups already set up and ready to go on day one. So the env really gives you the control to change it later. So, but again, it's out of the box like that, so it's really smooth.
So, Lorenzo, anything interesting you want to discuss over the setup of the Docker Compose from the observation perspective?
Yeah, I mean, if anybody's interested, we can go through the containers that make the monitoring part, of course. So, is my screen shared?
Yeah, well, right now.
Now.
No problem. Okay. All right, so basically what we used here is a derivation of the Homer and Query Compose, which is on our public repository. So it's a mix basically of Homer and query that we deploy in parallel. So it includes Grafana, but of course you can use the one that's embedded or bring your own. It includes ClickHouse, which is where everything gets ultimately stored. It includes query, which is again the endpoint and APIs that are designed to collect logs, the metrics, and of course communicate Grafana when it comes to displaying and querying them. Then we have Vector, which is in charge of fetching or scraping, I should say, a bunch of the metrics that all of our various components expose, and then everything else related to alerting and so on and so forth. In this case, I have a couple of head generators that just make some example statistics, and then Amplify from Homer. But in this case, it's configured in a very special way because it doesn't have a database. So this instance of Amplify receives everything that we have, so signaling, the RTCP statistics, and so on and so forth. But it doesn't write it to a database, it sends it into query itself. So it's kind of a chain. Homer is on top of query, which is then accessed by Grafana. So all of our, let me jump back, stats, for instance, all of our statistics that normally would end up in Homer, in Postgres, or in the main database, end up in query and in Grafana, so we can use them directly like metrics. So this compose literally includes everything that's involved with all of the elements running, and it's self-contained, so the elements only talk to each other, and nothing is exposed to the public. So unlike OpenSIPS and let's say the service elements that have to be reached by customers, this is an internal resource, so it doesn't need any exposure, it doesn't need any public ports, endpoints, etc. So it's completely self-contained. If there's any questions, of course, jump in. This is a workshop.
Guys, anyone want to drink something? Come on, ask some questions. We will start asking you. Lorenzo, you need to ask them a question.
I have a question. Is any of these elements unknown to anyone? I mean, we talked about some points of Homer, talked about ClickHouse. If any of these components you don't know what it is or it doesn't make sense, raise your hand, and I'm happy to get into a more level of detail.
Okay. Open. Turned up. Good. 1 second, Sam. 1 second. Just speak to this one.
Okay. Hi, this is Lorenzo. This is a question for you, really, about.
Can you hear me?
Can you hear me?
No, I can't hear it. Oh, well, maybe you can take the question and repeat it for me. It's the same.
What is the question?
The question is, it's about querying. So Homer would normally put the info in a database, and now Homer is putting it into queries. Is that going to be like the way that it works, like going forward?
The question is this.
Yes. I think I heard enough. So you asked basically this is going to be the way forward, that Homer flows data into query?
Yes.
More or less, yes. The direction of Homer 9 is even more generic. So Homer and query and everything else that we do, especially just going to write Parquet files. But for the time being, yes. So Homer is going to be stacked on top of query, or they're going to become the same thing eventually.
Good. Any more questions? Anyone else? Any questions about the topology or the new installation? Yeah.
Why us on the AMR? Why not?
Absolutely, because we're lazy. No, but it's we're part of the really it's about like still checking license stuff. We are still trying to convince the AMR transcoding is still not part of free switch installation. Also Asterix, by the way, it's still stuff that we are, actually we have a lab that goes that way. It's still, we are trying to be a little bit more careful from licensing perspective, but it's all about getting everyone aligned to the same license struct, but it's ongoing work, and generally we don't see for now any reason not to do it. Right now we are pretty much using the asterisk as the low word, as the simplest place that most common knowledge about doing like a low word with zip, you know. I know that everyone knows that if it can talk with asterisks, they can know how to work with it, you know. And this is like, I still think that like it will be the easiest place of doing a load echo application. Still will be.
Who knows what's echo in aspects?
What is the echo, Cindy? Good, we are the winner. Very good, very good. So we actually wrote a very complex diagram in aspects. It's a one line. It's actually echo. So 2 lines, 3 lines. Dump jump, echo, and answer, dump jump, and echo. So this is for you, for your answer.
Well, students must finish their pre-assignment homeworks before they can ask more questions.
Any more questions? Good, good, good. So who else want those strings? Good. Happy to see some great hands in there.
So just to recap, before we start drilling down into stuff, what you need in order to do that at home, okay? You need a strong computer, not too big. We have here, what is it, like it is an i7, isn't it?
Yeah, we got fancy and moved from i5 to i7 because just it was too annoying to wait for 40 minutes. So now we build this like 25. But generally there is not like a big consumption. We still didn't really did the high load of fonts testing. It's a hard thing to do. It's not like you can run CPP and run 2,000 calls and see when we are breaking it. I wouldn't put a commercial network over it. I would say, like, again, there is like for making anything that needs to support thousands of subscribers need to have dozens of CPUs supporting it, not something like huge, not any crazy amount of resources, but still it's, I wouldn't say that to run a mobile operator of thousands of subscribers you need a one i7 computer. This would be misleading. But to have in a lab and playing with that, that's fine enough. It can even be an i5.
One other device is, of course, the antenna Shlomi mentioned earlier. The Open5GS project have a list of vendors and other compatibles that you can order. That's like the big investment before you can have your own mobile network. And another, I guess, 20, 30 bucks kind of this device. This is like a SIM writer. It comes with an open source application that you can install and just burn your exe code, the secret, all the private identity credentials of the SIM and the subscriber into the network. We'll get to that soon. And that's about it. Just an i5, i7 computer, antenna, and this thing, and you're good to go. This one comes with a kit of 10 SIM cards, so you can probably burn it for all your family and have your own family mobile network to try it out. So that's when it comes to the driving to the hardware. We went over all the Docker installation, and now I guess we can start going over the configuration. So of course, forgot, in order to have a mobile network, you do need a mobile device as well. It's usually called UE, user equipment, just like user agent, but over the mobile network it's called UE, user equipment. And it goes for all the different huge amount of vendors, not just the regular ones we heard, Samsung, OnePlus, all the other Chinese, known vendors and unknown vendors, and they all come up again with the same, supposed to be the same compatibility to the 3GPP organization and standards, but again, they're not always meeting it. We found some cases that the older the device is and the cheaper the vendor and the brand is, the more likely that we will have some misbehaviors like auto-answering or losing reception and some stuff like that, so we can go over that later.
There is also a lot of different behavior. I will not go too deep about this. There is what's called the USIM and ISIM, and the ability to provision the URL of the SIM endpoint of the PCF, like the first proxy which the endpoint is connected with, is in some SIMs and some phone being able to provision it from the SIM card. Most time it's been automatically being concatenated from your mobile. Everyone know what is IMSI? Who doesn't know what IMSI is? Everyone know what IMSI is? IMSI. It's in the, what is the international, what is the...
Oh, you're the one that doesn't know what MC means. Got it. Got it. Different.
Trying to make everyone...
You were Wikipedia earlier than me. Subscriber identity.
So I don't know if anyone knows, but generally...
We had 2 drinks. Yeah. Best time.
So, generally, any SIM card that's being sold out there over the market that's supposed to work as part of the global GSM, who was supposed to be Alex Gage. Very nice, very nice. Well done, Alex. So generally, any SIM card that has been out there is being part of a range of that's been managed by the GSM global organization. Each IMSI card have this serial number. Each SIM card have this IMSI number that is like the serial number that is being built out of 3 different sets of numbers. We're talking, first one is the mobile country number. Each country in the world, like we have for prefixes for international calling, we have also a prefix for the IMSI numbers. The second part of the number will be the mobile operators in this number. So generally, if you got lucky and you are buying from your country a mobile operator license, you will get another number out of those 3 digits. So by topology, like the way that the GSM is being built, you can have up to 999 operator per country. So each, and then the rest of the numbers are the serial numbers that each operator can allow himself to have. What we are seeing more and more being happen, that this huge amounts of digits is being also being divided into different prefixes. So each MVNO that's sitting based on each MNO can use its own IMSI prefix that being based on the prefix of the country, prefix of the provider, and then some kind of internal prefix inside of the operator, which lead to the specific range of IMSI that each operator can provide. So after discussing this very interesting structure of IMSI, let's talk a little bit how to provision a SIM card. Sure.
Anyone wants to charge? Yes.
So generally, like we have this application, we have also a PySim. It's like a Python library that the geek person like to use to provision.
Sorry.
I was
making sure you're awake.
Anyway, So we can see over here, like we can provision the SIM card. So this is application. There is a few versions of it. There is a version for Linux, Windows. You can run your own, you can have your own card that's connected to it, and then just load and write the information. When we are talking about the information that we are writing on per SIM,
Sure.
so we have generally the GSM information and we have the LTE information. Most of it is the same. Over the LTE we have, so beside the IMSI prefix and the key of the phone, so each subscriber has like a key. This key is being used in us later. We will talk about it later when we get to the registration flow. So this is being part of actually the whole MD5 and being connected all together to know that we are actually talking with the right subscriber. So beside having the operator key, so actually this mechanism of the authentication in front of the mobile actually using the operator key and the client key, the KI that we're using for this phone. So generally, beside the main operator parameters, everyone knows the PIN that we have over a SIM card, that you can unlock or lock your phone with this kind of SIM, a PIN code that usually is being printed over the SIM card and stuff like that. It's very defense over the phone. Usually, before we were using it before more. Today, any login and authentication in front of your phone is not based on your PIN of your SIM, but based on your some kind of authentication method, or even in front of authentication provider. But again, this is the major thing: the KI, OPC, and the IMSI himself, which will automatically calculate the MSICI, the PIN, and everything. Is actually different numbers that being automatically calculated by the same IMSI number that we declare.
Just another quick thing, once you set up the first SIM and it's all working correctly, it's very easy then to just read the card, and then just change the numbers, change the settings, and write it back to a different card after you replace it. So you don't need to go over all these forms several different times.
By the way, I was just talking last week with Giovanni, and part of the idea was maybe really building also some kind of provisioning tools to the SIM that will be part of the community effort. So to make sure that the same system that provision new subscribers into the system will also do the SIM subscription itself. So when we are talking about the next steps of subscribing SIM into the system, we will see it still like being divided into 3-4 different places beside the SIM card itself. And really we are in an effort to consolidate everything into one UI. We are getting a lot of effort and resources out of the OpenSIPS project that are also very much looking for it. They love to do any backend that we want. Please ask us to do any front end that we can do, because they are less in this world. So we are working together to unify a lot of the interfaces. So what you will see now by Nitzan, that we are talking about provisioning the OpenSIPS and then provisioning the HLR, and then provision another service that called FHOSS. In the end, we are all working together to have it all in a new UI that will automatically provision all of those information to all of those microservices as one point of integration. And of course, Giovanni said, if we are doing all of that, that's already do the whatever we need with this SymPy. That is a library in Python that gives us the ability to provision the SIMs themselves and to have also the SIM provisioning as part. Sam, you want to have the stage?
Yeah. So, once we set up a SIM card with the right credentials, first we need to make sure that the network is connected. So, when looking at the antenna itself, once it's plugged in, of course, you have like green and red lights. Guess what? The green light means it's on and good. The red light means it's off. This is like a basic outside of the box without even logging in to see just if the antenna is logged in. You have the EMP, the SRS EMP. Actually, freeze and let's just discuss for 2 minutes what we're looking at. And it's important.
Can you start first showing the EPC provisioning and the NHLR and then do the FHOSS and then let's go to the antenna.
Okay. So, as you can see here, we have the UI for entering new subscribers. And you can set up the IMSI, you can set up the K and the OPC. Do you want the microphone?
Yeah.
Oh, go on.
So generally, we are talking about 3 systems that we need to provision each one of the SIM. The first one is the OpenSIPS, which is generally about provisioning the SIM for the EPC level to give in all of the data, all of the APN. We know how much APNs do we need to have a phone call, for having a phone call inside of 4G. First of all, who know what APN is? Access point network? Neither of you never APN of mobile network? You know?
It's like an APN setting for like network for like registering.
Exactly. So usually when we are touching the APN, it's because we have some kind of issue with the provider serving the internet, right? Usually when we are talking about APN, we are thinking about the default, what's called the default type of APN, which we will go inside of the subscriber. We can see. So we can see that there is a default type of APN that in our case called the internet. By the way, it's the lower quality classification indication, the UCI, it's the higher one, so it's the lower quality of service. And this will be the internet. But for having an IMS, and all of the concept of IMS, why do we need IMS if we just have internet? Why the Shlomi, you're wasting all of our time in talking about something? We all know SIP, we all know what is the serving with the internet over the mobile. So the idea is really that we have another kind of IMS, of APN that called IMS. And this IMS is this APN is being used for all of the high prioritized traffic. Actually, it's not the highest prioritized. Anyone have an idea what is the most important APN in a LTE network and how does it call? SOS, it's QCI 0, it's for any emergency call. So the idea that even if you don't have a SIM card and you are always being able to subscribe at least to the APN of the emergency calls and make emergency calls there. So there is a whole different kind of APN running out there, and when you will go inside of your APN setting, you will see that you can separate which type of APN traffic you are using inside of your mobile for this application. Each APN provides you a different IP. So when you are lighting up, we will see it soon, when you are connecting the device into the system, you are getting one IP that is being based on 192.168.100.0/24 to the any for your default internet, for the default APN, and another one with 192.168.101.0/24, which each device getting for the APN, for the IMS APN, which any SIP or RTP or RTCP packets will be moving through this APN, and this network will be prioritized with much higher performance, and the carrier will know to guarantee you the bandwidth over the radio when you are starting a call, which never happened. Nobody guarantee you anything once you are opening YouTube or Spotify or any other adult viewing site. And so, after subscribing into the and setting up all of the information inside of the EPC, we need to subscribe and set up all of the information inside of the FHOSS, which is the home subscriber network service for telephony service. There is an effort for us working with the EPC, with the Open5JS, to get all of those HSS services as part of the Open5JS. It's something that actually we are now working as part of the front-end efforts discussed to be able to manage all of those information for which dispatcher set each SIM should go to, or any other kind of those information. We are trying now to get it also to be a part of the Open5JS interface that you saw earlier, which we until now using only to manage the APN and the different information about the data subscription. But we are also planning and shortly working with the community and Open5JS author to make sure that we will be able to provision it all from one interface. When we are talking about the different kind of stuff that you need to provision inside of the telephony side of the HSS, so we are talking about, go to the FHS? Yeah. So we are talking about the IMS subscription by itself. So first of all, so we are generally setting up the subscription. The subscription is actually being your IMSI number. As I was saying earlier, if you want to use demo, usually you should use 00101. This is like the demo country, global world 001 is a global or testing, I don't remember what the definition exactly, and then 01 is your default demo network. It's actually, you can get a legal problem if you are starting using different stuff of different subscriptions, especially of the radio stuff. There was this article of the university in US that made a single radio like this that represent each time a different SIM card, a different mobile operator, and send to the old crowd the presidential alert and fake alert and push into the phone. So it's really easy to make you register into a different network, and we can discuss it later, but you should not get in trouble, especially, so don't play with local numbers, MNO numbers of your local operators. Beside that, we can see after the domain of your IMS. Can you check all the way up? So the domain of the IMS, can you do a little bit control minus? Yeah. So the domain of your IMS subscription is always will be IMS dot your MNO number MNC number, and then MCC number, dot 3GPPnetwork.org. This is like, this is a convention of generating IMS endpoint per operator in the world based on this convention of URI, of email, like an email URI. So this is anything about the IMS subscription. Again, there is setting up which prefer SCF and capabilities. Anything that is really about provisioning the phone behavior of this one. Generally, you can say if you can go to a different proxy or a different initiator. We will talk about it later when we will look a little bit over the demos. Beside that, there is the private identity. The private identity is actually all of the information about that we already have, mostly inside of the OpenFive.js. So we are talking about the identity and the secret key and the OP number or the OP. Go down. Actually, the OP or OPC number, usually we are using in 4G and above the OPC code. And there is something called SQN, which is the specific implementation of this SIM inside of this network. You can see inside of the OpenFive.js. If Nitzan, you can go to the OpenFive.js screen. You can see the SQN, SQN that we set up. So yeah, this pretty much, there is a different types of authentication. For now, we are actually only did the digest MD5. We are working also with the OpenSIPS guys of implementing the AKV1, AKV2. Those are all stuff that ongoing work to support inside of them. And for now, the demo that we will see will be based on the MD5 authentication. Beside the private identity, we have the public identity. It should be like giving us the ability to set up the DID, the direct inbound number behind it, or to set up even a SIP identity behind it. Really about connecting the public identity that will call to this private identity. Make sense? It's a little bit messy, I know, but it's not me, it's a 3GPP. Yes, we have a question out there, finally. Please, hopefully.
IMS to understand this better. I understand it's of the signaling media is all data all secured. Do we have to use some kind of CFS TLS that somebody can hack it or not? That's one question. The other side is other question is when we make a call using this setup, let's say I dial my cell phone, what happens on the receiving side in terms of signaling? If light on that would be
of course. So the question is again generally in two different directions. One is really how is this our data is really secure inside of the mobile network operator. So generally between the phone and each packet that being sent between your phone and your radio antenna is being already inside of this tunneling, this radio tunneling. So it is being with some kind of encryption. It's not like I can start monitoring any calls that are being around in here. There is that from the radio perspective, of course. From the signaling perspective, there is also the IPsec implementation that we are working now that let us, after the first unregistered or invite, sending a 400 to one unauthorized that actually telling that you need to go back to a specific IPsec tunnel. But this is a different thing. Generally, if it's secure between you and the antenna, it's secure. Above your mobile operator level, it's it's like in any other VoIP operator. Even if you're using SRTP and TLS, it's up to the point where you are really terminating it into into a PSTN network where usually it will not be already encrypted. So it depends on on which level behind the radio network, which is really what would be being concerned about as privacy as consumer. Not inside of the radio level itself, where there is already a good mechanism of encryption and making sure that each packet can only be consumed by the UE that generate this connection. Yes, answer your question? Yeah, good, good. Is there one? Anyone? Everybody else? Any questions? Anything about that? Okay. All right. So if we finish all of that, let's get into the fun part of it.
Yeah. So first of all, just to introduce the Portainer. The Portainer is a wonderful open source up to 5, right?
No, it's open source. There is a community edition, which is totally open source based on Go. There is a commercial edition which has been given free for users to up to 5 instance installation. Of course, everything that we're doing is based on the community edition. Portainer has been a great tool for us to simplify the Docker deployment. Is good for from running. It's given us a great UI and observation system for anything from a lab that's sitting over my laptop to Kubernetes cloud that can run on any other providers or on your own private Kubernetes cloud. So it's very helpful tools for us, and we are using it a lot. We are actually discussing about doing some community efforts about building Portainer templates for OpenSIPS, so different kind of default implementation of OpenSIPS and installation of OpenSIPS will be able to install based on ready template. As you were saying, you can have template. No, never mind. But you can. The idea is really to build the ability of easy installations. Of the antenna, talk a little bit about the issue.
So I already turned on the ENV.
So SRS ENV, as I was saying, the SRS project is our radio access, our radio software-defined network software project that we're using. And there is SRS ENV and there is SRS GNB. SRS ENB is for the 4G. We are now working over the 5G implementation in front of the with the SRS GNB service, which is also under the same project of the SRS run, which now also provide a binary that called SRS GNB. But for now, if we're looking over the SRS CNB, let's go inside of it.
The SRS?
Yeah.
Command line.
No, go to the log, maybe do a restart, and go to the log and do a restart.
Yeah, just click that, let's go to the log.
Good. So actually you can see, scroll up, cancel the auto refresh. Scroll up.
This?
Scroll down. No. Okay. So actually we can see now over here the log of this service when it's running. When the service is running, the first thing is looking for the seeing if it has its own configuration file. If not, it is creating those. And the first thing that actually is doing is about connecting, looking for which radio it can find. And scroll down a little bit more, we can see that is describing, is detecting that is finding the B210, the US. It's actually this device sitting up there, and might see under the screen, running. And it's very important to say I lost so much hours on that. Only working with USB 3, no 2.2, no 2, like everything's look great, and then you are getting like really annoying USB lib exception. So making sure that when it's going up to see that it's USB 3, make sure that your port over your computer support USB 3. Don't lose time as I lost on that. Beside that, the really thing that is doing some sanity check in front of the device, and scroll up a bit, like because it was a restart, we cannot see it. But usually, if you would scroll all the way up, you might see it over now. It's not in the history already. Like if we will just disconnect and connect it from the power, we will see that it's actually loading the framework. And it's taking up to 20, 30 seconds, but each time that the device actually losing power, we forget about the framework of it, and then when it's going up, it's sucking up the framework from the application which is managing him as his controller. Alright, and then we can see like over here, I have this device, and if I will go into airplane mode, I will probably see in here, put on flash. So you see now I got the disconnection. This is mean that the device actually disconnected from the antenna. Of course, there is like, if you will look on another 20 different microservices that add event and add some activity because of this registration. But from this perspective of this service, so what is doing that is opening the radio channel and close the radio channel. It's actually trying to be pretty primitive, the SRS-ENB, from the perspective that most of the magic of the EPC, of the packet management is not over the radio network, but over the core network. So if we now doing a connection, I'm getting connected to it, and I can serve the internet, and I'm like connected to the network. Once I'm getting the 4G, it means that I got an APN default address, and this APN default address has the ability to go to the internet. Another thing that's going in the background, while I'm doing the connection and disconnection, is actually the registration flow. And before I'm getting into the registration flow and really the spec and then seeing it in SNGraph and then seeing it over the trace with Lorenzo, anyone have any questions about what we're going so far? You will not need to drink, I promise. You can ask questions without drinking. No? Okay. What? All right, the other way around. Do you have questions for them, Bogdan? You have questions to the audience?
Just ask.
You just ask it. Okay, so what is the next, Nitzan?
Yes.
You're the one with the
control over the computer.
No, ask questions. The audience.
Of course.
Someone to drink.
Okay. Who knows what HSS, HLR, HSS are? What are they?
Home location registry and visitor location registry.
Almost, home subscriber.
Close.
Yes, and what do they do? What is their job in the mobile network?
Telling subscribers in their home, the seller, their roaming, kind of thing, right?
Kind of, yeah. So the HLR, the home location, is about, just like user location model in OpenSIPS, that's the obvious, in this form, the obvious example for it. It's where the mobile network remembers and stores the location of each subscriber, so once an incoming call is coming, or a message, or whatever, he knows where to look for it. And the HSS is actually the database where the mobile operator holds those.
Yeah. Deep into the specification. This is your thing.
Oh my God. This signaling board, so exhausting. So, look at the flow of, and I will follow with you now the questions that I think you just asked about previously about the signaling flow inside a mobile operator. So you can see that the regular register that we all know with the 400 unauthorized, with the user digest, and then it goes again, and sends another register with the OK200. Usually, all the the registration mechanism is only done between the client and the server. This time, each one of the servers in the IMS needs to verify first if the identity exists in the network, and then if it allows registering. So the special thing, if I would try to, try and say in one sentence, what's the special thing that's happening in a mobile registration process versus just a simple SIP registration, is those extra calls that are happening. If you can see, I'm sure it's too small for you, but just to make it clear from here, yeah. So we have the PCRF, the HSS, and then the PCSCF, and ICSCF, and SCSF. So
maybe you can give just some reference to the document so people
Yes.
understand.
So the document we're reviewing here is actually the GSMA organization standardization for voice over LTE services. It was out in December 2014. We haven't found any updated any updates for that specific flows and diagrams, even though they mentioned it might be changed in the future. It still holds the same flow. And of course, all this document is part of the 3GPP standardization for doing those flows. And going back to those, how much pages was it? Yeah, so it's a simple 175 pages long document that really specify all the micro flows of all this standardization, but going over one of the basic ones, which is registration. Yeah, here we go.
What is important? No. Actually, what's called the single mobile operator flow. So later on in this document, we might even send this document later for who is curious inside of the Slack group. There is the much more complex registration flow when we are talking about roaming perspective. But for now, we don't want to get it too complicated, and we are trying to start with the basic IMS infrastructure. So we are talking about a single mobile operator world. Of course, the world is not like that, and you are always needed, even if you are having a full coverage in your own country, you need to give roaming abilities to your users. So full flow actually is a little bit more complicated because you have another interaction between the different operators.
Yep. So, even though we're used to looking at the flows of signaling like that, I will go a little bit to a different diagram just to try and simplify it before we go back to the regular signaling. So we have the EPC side, the radio side, if you may, on the left side, and you have the IMS. All these three instances are actually OpenSIPS deployments that we will go over their templates soon. And they are the core part of the IMS network. And if I would just simply give out the registration flow as it goes, is that the user agent, as Shlomi mentioned, using in this lab stack, the 101.0/24, which is the subnet for the IMS communication, not the internet or the others. So, sorry, is that Lorenzo asking a question?
No,
Alexander.
Yes, joining.
Wow. Sorry, Alexander. Yeah. Sorry, everyone. Welcome, Alexander.
Keep going.
Yeah. I'm going. Where was I? Yeah. So going back to the flow here, in a simplified icon way, is that the phone is sending the register over the radio. Now there's all this UPF and PGW. It's all this sub-networking of the mobile network, because obviously the mobile network needs to support more than 255 subscribers, or how many hosts you have in the LAN. And using that, it's actually moving the register packet into the 172 LAN, into the network. It's kind of like a network NAT, if you may. And the register is passing from the radio network into the PCSCF. The P is for proxying, so it's important to notice that almost all SIP dialogues are passing through the P, the proxy CSCF, and the PCSCF then sends the register request to the ICSCF. And usually what would happen is that you would reply with a 401, but this time the ICSCF is checking the UAR, the request, and then the UA answer is checking with the HSS if this subscriber exists, if this identity exists in the network. After the request has been replied back, it's not enough for him. Now he's going to the S, to the services CSCF, to see if this user is permitted, is he granted, is he, for example, while roaming, is he allowed to call? If he didn't pay the bill and we shut down the subscriber, he should not be able to make a call, right? So it's checking again with the MAR and the MAA replied back. For this,
it's fair to say that like part of the WW authentication mechanism, like the actually nouns is being provided over the media authentication request. So part of when the SCFCF is making the request for the media authentication request over the media authentication answer, it's make almost sense that over the media authentication answer you will get the nouns that will later enable you to do the full authentication in front of the SIM card.
So once the SCFCF is replied back from the HSS, it replies back to the ICSCF, that replies back to the PCSCF, which finally replies back to the device with an OK200. And this flow is something that we will definitely do now. We will open a Wireshark and SMGraph and see it in our own eyes in the views that most of us are used to seeing. So first of all, let's move to, again, this flow is obviously described in this document again. And we just show the reference, just the first diagram in this document is about the registration, and it's found here. So you can see the same thing, the register to the PCFCF is sending the UAR, reply back with the UAA, and then it's registering, sending another one, and then the unauthorized which impact the device. Again, the documentation.
Sorry.
Bucket form.
Okay, let's go and get into the OpenSIPS servers. Wouldn't you be?
No. Maybe run from the SSA, go to the host and run the SSA.
Oh yeah, for sure. Probably have more links there. Here we go.
So generally the first thing, the first thing I will do will press airplane mode. What would you expect over me pressing airplane mode from a SIP perspective? Register, which expire. We will get register with expired 0 just by me pressing the airplane mode. So
I saw you marking 0. You deserve whiskey.
You were my colleague.
So after I will get out of this register, we will see all of this flow of the registration. So we can see the first 168.
Let me get the font a bit bigger.
So we can see. So we can see all those 4 registration point, all of those endpoints. So
that was too much. Sorry.
You're making people puke. They didn't drink enough. No, they could puke, and now you're using another excuse. You have no art.
Let's go with 16, I guess. Good enough?
Alright, so we can see the 4 point, right? So as I was saying, the 192.168.101.14, this was the IP that I was assigned by the APN of the IMS. This is the IMS IP of my phone. We can see, actually, we are seeing those packets over SNGREP few times because we are doing SNGREP of any. We are seeing it on multiple networks. So we are actually seeing the same packets on both segments. So don't get confused about thinking those are 2 different networks. As we can see, the user agent is my Open Plus. OnePlus with all of the information framework. And we can see the authentication request coming empty. And if we will scroll down to the unauthorized, unauthorized with the open this. So we can see over here all of the nouns that came in as part of the media authentication request that came from the diameter. And if we will go and see the next registration, we can go inside that you have all of the different C nouns and C nouns and all of those kind of different parameters that we are seeing as part of our digest MD5 authentication of the 3GPP. But in the end, it's pretty much the same as we are regular from any MD5 authentication, which we are having the response, which indicate that we have all of the information. In our case, it's mean that we have the right user information plus the key that being stored inside of the SIM card that we put later. Earlier, if you remember, it was all once. So yeah, this is it. Maybe we can try try here from the back, see if we can, we'll go physically into the Wireshark. Oh. So this is Shlomi using the screen that you're seeing in mirror view from the back. Don't make fun of me. After drinking too much, I would be able to do it on any other day, but So we actually start capturing Wireshark over that same i7 device that we were discussing. We just switched the HDMI view to see exactly what this small Debian machine is. And if we would succeed running the Wireshark, we will do the same. And the reason we want to show you the Wireshark is because obviously it will capture not just the SIP network graph, which is what the SN graph is capturing, but also the diameter request that we showed you earlier inside the flow. Yeah, good enough. Yes, we got it. The capturing has started. It will end up on the filter, the SIP and diameter flags filters. So we only see that out of all the rubbish that's coming out in this network. And as you can see, it's as simple as SIP, pipe, diameter, just the name of the protocol. And now you want to clean it up and do a... Do you have the phone on your? Oh, I have it. Yeah, I have it. So I'm moving to airplane mode now. This is the reset. I don't see. Yeah, and the middle one. Continue without saving. And middle one here. So I'm on airplane mode. Cleaned it up. Are you ready? Started. I'm doing the airplane mode. You see all the registration coming. Firewall 3 implement, not implemented in system. No, that was like the subscription, but you can see over here. With the same register with the unauthorized, and maybe you should filter just for diameter or just. You can see over here. Yeah. So so you have the mouse. So I will point out. If you scroll a little bit just to show the UMR and UIR. Yeah, so if you open up the headers, the session. So part of those diameter requests have in the, actually you can see it in the outside here. If not, probably if you open that here, the diameter protocol itself for a moment. Maybe we should just look over your file. Yeah, okay. So again, what we're seeing here is the same flow that we were discussing with the register, but this time we also have the diameter. It was very helpful to see it in order to, support the different scenarios that we started practicing over the mobile network to make sure that we have like the transfer, hold and hold, other actions that the user agent is doing while in dialogue. So it's very easy and good to see in Wireshark in depth the communication over the diameter. You want to maybe mention a little bit about the HTTP2 communication? Actually, whatever we are discussing now, it's all relevant to VoLTE, Voice over LTE. As the 5th generation is already up there, massively being deployed for generally for data purposes, with the VoNR implementation, what's called the voice over new radio, which new radio is like the name that they make, they call it the 5G. The voice over NR interfaces for the 3GPP are more based over HTTP2 interfaces. They are moving a little bit away from diameter. We were planning actually to do a big project over OpenSIPS to make it support HTTP2, and then we realized it's already supporting because like the way that so HTTP2 is really almost like HTTP. It's like even one step before HTTP3 that Dan Jenkins had very interesting discussion yesterday. But when we are talking about HTTP2, the main thing is about having the ability of having one open connection and have multiple requests being served over the same connection. Pretty much sound like a great idea of for what the requirements of such an integration between, let's say, IMS and HSS or any application to application constantly eating API. So if we have two applications that constantly talking between each other, HTTP2 is a great way of implementing it. The way that OpenSIPS is being implemented, it is over the CURL library that actually know to manage its own connection pooling and doing this magic background that manage the connection pooling in front of all of those applications. So hopefully in the next few weeks we will announce and publish the setting of how to run the IMS for the VONR.
Lorenzo, you with us?
Yeah, well, I'm just, first of all, amazing work. I mean, for a moment I forgot that I was even part of it. This is like, an amazing amount of work that you're presenting. But, on the back, I just wanted to see if we want to go level by level. We're accumulating like a bunch of things that we're going to have to look after in the future. So you mentioned quite a few of them. If you want, can make a quick parenthesis on how, we keep tabs on all these additional protocols, elements, application, etc., etc.
Sure, go ahead.
So, I'm gonna go backwards. So when you're developing like the guys on the box and whatever, you need to look after teams. You're gonna be looking at things locally, as the grab, Wireshark, and everything else. But of course, as you scale up, all of these things have to be automated, which is part of the direction of the observability of this platform, which is to put everything on the same level, right? So the SIP messages, diameter, these sections that Alex can get into if you want to, and everything else, they, by design, end up in the same troubleshooting level as the HTTP requests that we were talking about, the application logs, and everything else. Otherwise, it's almost impossible to make sense of them, right? So into the same environment, and here I have just a quick, example of something that's part of an API. We can track what the APIs that run the calls and that trigger the actions are doing, and then go and jump into the process of those calls internally. So we can literally attach these to as many of the elements, and of course the community here is going to be important to identify what needs to be troubleshooted first and second. But we want to get at the level where we don't have to like asset grab or anything else in real time, or we can grab the present and the past using everything that we're saving all the time in query, right? So now it's see penalty speed, and we're going to add diameter, then it's going to be together with all the logs. At some point, you can just jump and query anything, whether it's your application, with the stack, with the Kubernetes cluster that's running the container, or looking for a specific message that you might have just flowing around in the system. Oops, I skipped. Alex, you want to say anything about throwing the diameter into querying for the context of this? Because then, of course, the correlation changes. We go from SIG local IDs to IMCI.
Yeah, okay. Yeah, of course, especially in IMS system, you have to exactly capture diameter because you need to get information to authentication and to accounting, etc. So, and unfortunately, with diameter, it's almost impossible to correlate to the real SIPs call, SIP protocols. Therefore, you have to capture everything and try to correlate it manually. And this is
well, then we just use the logs.
Yeah, it's logs. Yeah.
it's in the log. So on one side, we capture the raw protocol. In the middle, we capture the logs of the application that's actually happening. On the other side, C. And when we put them all together, you actually don't have to make out or guess anything.
Exactly. It's a situation. When you get everything in logs and the application is already created for you, it will be easy to maintain. I'm talking about if we take each separate protocol outside, yeah?
Exactly, that's exactly the point that I was hoping you were going to make. So that alone, all of these protocols are super hard to troubleshoot unless you know where they come from, what they're for, what they're correlated with. And if we look at all of them at the same level, you guys, I guess, can understand where the troubleshooting of this platform might be going. And a quick example, screenshot. I didn't really understand much about this until I saw it. So this is the type of graph that you can get out of the work that the guys are doing. What's actually talking to what, and how much of it are they exchanging between them? What's the actual flow? We can look at it from a protocol perspective, but also from a functional perspective. These containers are talking to each other, which means that they have a relation, right? So many layers, many steps that we have to mix and match.
So the documentation will make exactly a good let's say, execution system to show what really works, how it really works, how companies communicate to each other. So, and here in this help, in this ETF especially, you will see the full pictures of
at the end of now it was just a parenthesis in the context of mentioning all of these protocols and all of these new data sources that we're gonna have to look at.
Yep.
Thanks.
Thank you very much. So let me go smoothly from seeing this nice view of the presentation screenshot straight into the real code itself. So Lorenzo, you want to say a few words, or I can show off with this amazing tool?
Show off. I'm just going to say this is all data that's collected in real time without modifying the applications that we're looking at. So it's all happening passively with eBPF, injecting pieces of code, watching functions, etc., so that we can passively observe what the entire stack is doing, what's talking to what, etc.
Yeah, it's just two words from my side. It's a kernel level, so no any interruption for real application. It's containers, can be Kubernetes, can be different setups. And this external application, it takes all kernel signaling and show what is happening on this system.
Yes, show off.
So especially when you are deploying 40 microservices at once, you really want to see some visibility to what the hell has been going on behind those millions of rows of codes that have been triggered. And it really comes out of the box beautifully done in a way that you can see each host. You can see the amounts of requests that each one of them is doing and to whom, in which port, the capacities it's consuming, the resources that each one of them is, the state of his performing. You can see that this one has a green CPU, but he has a yellow storage, so obviously the MongoDB needs some clear outs or expanding the size. Again, this entire box and all those microservices, including all the beautiful metrics and measurement tools that Lorenzo was discussing. It's all coming on one i7 small box, so it's pretty neat. And compared to many other NMS, network management systems that, like, Netcool, PRTG, Cacti, all those SNMP, this one really comes out of the box with the.
I think so. I think it's also important to say that one of the greatest things that the revolution of Homer requiring and using tools like code that, like, yeah, you have your own basic dashboard, you have your own UI tools, but in the end it's all sitting out on those different databases of yours. So any information that we are seeing inside of code, being generated out of the ClickHouse that being sitting inside of it. So the ability of later building your own data sources and your own charts and your own visualization and your own alerts over it is the most important thing about it, because it's one thing of really having some cool things out of the box, but the abilities later of taking those cool things that you have out of the box and really customize them and really build whatever your organization needs with the correlations that your organizations need, with the thresholds and any other thing that you dream out of observation and monitoring and alerting system really can get out of the box. A lot based on the big open source community that are sitting behind Grafana and all of those observation and open telemetry and other few wonderful open source projects that giving a really good solution that being maintained and supplied by the community effort.
Great. So,
well said.
Yeah. You want to show up with the boards, or you want me to show up?
Oh, show up as much as you want. I can get into detail, like if there's anything that we want to explain, bounce it to me.
No, I feel like really, I wonder if you can show the guys a little bit how easy it is to modify those stuff and to build your own stuff. I think that like people are here a little bit not aware of how easy Grafana it is and how easy it is to you to build your own dashboard and stuff.
Yeah, absolutely. And again, the beginning of the solution is to make everything the same, right? So if you have to know language for log, language for metrics, a way for signaling and everything else, at the end, it just becomes complex. Do the job in the first place and then to compare this. So the first thing that happens here is that everything is the same. You can visualize it, you can make charts, real-time logs and whatever, but at the end, all of the data is the same database, it's accessed and correlated in, let's say, compatible ways, so it's really easy to stitch it back together, even if it counts as a completely different thing. Here we have an example, like just basic things, so 3 widgets. One is looking at the fractional loss, and we have a threshold set, so we can set alerts on what's going on here. So if, let's say, we know that this is a function or parameter that affects our service, we can just configure a threshold to look after it. If I go here, yeah, so whatever. If I go here, I can super simply say, okay, if the fractional loss is above a certain percentage, or if it has changed in a certain magnitude over the last 5 minutes, or over whatever logic they want to apply, it's as easy as this. You take the query, the same query that you use, visualize something, and use it to make another. So that you can get going with things, so even ad hoc and in real time. After which, it's since everything is the same, it's really simple. So here we have some type of event or something that's concerning, and I'm automatically zooming into the events from which we have determined this packet loss or this fault. So again, putting everything on the same plane, and down here we could have the logs of the system that's sending the call, media measurement from our application, some client logs that are coming from a browser that was involved. So again, it's about putting it all on the same plane. When it comes to visualizing and so on and so forth, the second secret is to make it industry standard. So Grafana has, I don't know how many, 10, 15 million users, great documentation, continuously updated, and by making our data the same as everybody else's, the same as Prometheus, the same as Grafana's own log and tempo, we just basically allow all of our users to take the millions of recipes that the data science guys are creating in Grafana and just use them. So you no longer have to convert everything from scratch. You can just take something that worked in another context, another environment, and apply it to your data in a super easy way. So standardizing and going all under the same roof, I think is the big the big change here. So Omar is going to write here, Corroot is going to write here. This is also to answer the previous question, right? Corroot is an application that is on top of queries APIs. And Homer will be the same. Just something that pumps data into the platform and then uses it itself, but allows also all of the other applications. So here Grafana is just the client, but again, as we were seeing, I can access this data from my console, I can access it from my own application. You can do literally whatever you want. And since it's 100% compatible with those standard protocols, it means that tomorrow somebody else makes a new UI for the same APIs, you can use it instantly, without modifications, without hacking a line of code. So making it easy is the secret, because then the data that's underneath is not easy at all. So troubleshooting IMS and all of this stuff is going to be, quite a job. So making sure that the observability is accessible and simple and easy and at a glance is the best thing that we can. Not knowing what problems we'll find, we just have to make them all equally easy to reach. And again, it's a mix of logs, traces, metrics, and good old packets.
Great stuff. Thank you very much.
Anyone have any questions from Lorenzo or Alex? Anyone just want a free drink? Very good, very good.
So Alex has a question. No, it's not.
So, I'm taking it for you. Don't you be worried. You will come.
That's going to be a big question.
I'm sorry, yeah, I will share the screen here so you can see back what's going on. And just to say thank you again for Lorenzo and all the hard work that he's invested in making all these beautiful things come right out of the box of this container. So thank you very much, Lorenzo, and Alex, Thunder, and all the gang, Kieran and Homer.
You guys make it fun to do this stuff.
Absolutely, absolutely. Great. So cheers for that.
You're welcome.
Thank you. So I think it's time for another SN Repo. We'll do some invites.
Yeah, let's see how we invite.
Okay. I'll go back to the container now. Let's
maybe start a little bit discussing generally just the flow with the diameter. Can you go into the spec flow? So generally, again, when we are talking about calls over diameter, over border, it's pretty much the same, beside one thing that when we are going to handle, when we are engaging the RDP engine or RDP proxy, or the second that we are opening those SDPs and knowing that the radio network should prioritize this traffic that going from this phone port to this, we need to tell the radio network to keep those sessions alive and prioritize them. So go to this is
message sequence.
So generally over here we are seeing after that we are getting the 200 okay, just on the second that we are lighting up the network, there is those diameter requests that are in charge of prioritizing the traffic and making sure that the what's called the radio barrier, this old tunnel of communication between the phone and the media gateway over those media real-time protocol traffic will be prioritized. By the way, in the beginning, one of our tests, we didn't do this right, and then the phone itself was sending ourselves by each time that we were answering, and then after we got into ADB debug inside of the Android debugger, we were actually saying that he's complaining that you motherfucker, this is wrong QUCI to make this kind of void call. Please set up the right barrier for making it. He was actually saying it in a little bit more polite way, but still, it was very nasty for a dog to talk to me like that.
Especially it took you like 3 days to find that line of code. So, do you want me to make a call?
Yeah, let's make a call.
Let's clean out the history here. It goes on and on and on. Let me switch back to the small fonts.
So generally, as we expected, inside of a single operator network, the invite will go to the PCFCF, which will go to the ICFCF, which will go to the SCFCF, which will decide that you deserve to go to the media gateway. In our case, is this amazing asterisk with AMR product. And if we will do F3, down there, we can see those amazing RTP AMR packets going through. I guess we can skip going inside asterisk, so we want to go inside asterisk and
echo?
Then, I don't know. Maybe someone want to see how you do an answer and then echo?
Who didn't saw Flavio showing what echo is?
Very good. Everyone. So generally, this is what it's doing, getting the packets into the AMR and the asterisk, sending them back all the way from the phone. We can see that actually, in our case, we've been a little bit of lazy and did the route between the 192.22.0.0/24 network, like the Docker Open5JS network. We did a route from this one to the cell phone network and to one of the ingredients, one of the microservices inside of the Open5JS that we are using as our gateway there. But generally, later on, of course, it's best practice to put the RTP engine or RTP proxy inside of the API network of the 192.168.101, and to make sure that those networks get full routed to the back. You don't want to have your UE user equipment being enabled to be routed inside to your core network. So of course, the best practice, this is not recommended, and of course, you should have some kind of RTP proxy or engine between your IMS APM and your IMS core network. Any questions about calls? Yes.
So, have you ran into like RTT and some of the other protocols? You said voice, voice here, but there's RTT, real-time text, and a few other ones that are native behind the side. Have you got to play with that at all?
SMS, there is actually part of the installation, the SSMST that we are still working on it. Actually, it was enabled in the other folks that we were getting our sources from. We are now going to do it. The real idea is really to try combine it already with the the new level of instant messaging content. So we are really trying already to connect it all together. So not only supporting the basic SMS, but also supporting rich content text messaging.
And then I had another question too. So have you worked like the LCS or the LRF at all in the IMS? There's really more location where basically the device is reporting its location back.
No, it's by the way, it's a very difference between implementation of implementation and a network and a network.
Okay.
We are less about that. This is more about part of the EPC side.
Okay.
I might not giving you the right answer from the Open5JS perspective. Need to check about it.
Okay.
Yeah.
What happens now when you have a device that falls back to 3G for calling?
This is actually a good question. This is one of the challenges that we didn't handle yet. But the idea is really having a circuit switch fallback both way. So the idea is really to be able to move the call. So it's really reminding us a little bit of mid-call refer. So we are actually working on it to make sure that if the call, to take the call that is working on one media gateway and reinitiate it in front of the proxy that having it, it's actually almost like referring a call to a different, think about like doing a refer between two calls that are sitting on a different media gateway. This is pretty much the active, how look behind the scene of circuit switch fallback, because it's actually, you having one call that was discussed, you have this one endpoint that was relevant, and now you need to move it all the way from RTP perspective for a different one. Is almost like doing refer between two calls that are not sitting on the same server. You just need to do some kind of a sandwich approach and reconnect those calls to be able to get those strings and continue after you are moving to the other network.
So, and the 5G open source project, has there done a fake SGSN and a fake GGSN?
Yeah. Want to answer that?
No, sorry, we talk about it.
So generally, yeah, it's like it's doing it's changing the interfaces there mostly to be the HTTP2. So they are a little bit differences the diameter, but generally they are from theoretical perspective there is a full implementation of all of them. From practical implementation, not all of them are being tested yet, and this is really what we are getting out of the Open5JS people. Help us test, because like by the spec everything is working, but the real life and the specs are very different, and we're finding ourselves, and this is really the community efforts that we are all inside of it. Okay. Yeah, Flavio.
Yeah. Let's suppose you have a Suppose you have provided an IMS for a company and they are still having some hours with 3G.
You need, first of all, they probably today have some kind of activity. They have already their circuit switch network. So each network, most of the companies that have 3G, nobody is building now 3G circuit switch soft switch, all right? This is, I guess, you need to be crazy to look for some kind like that. But you will still have but any network that is being based on 3G before have this own circuit switch application. So in the end, it will be moving this call that's sitting inside of the media gateway that came from the IMS into working, redirecting it, referring it into the 3G. If the call is, if you are in the middle of a call from 3G network moving for 4G network, is the same concept. You need to refer the network to, you need to make sure that you are doing re-invite for the same call and sending it into the other network. So yeah, this is pretty much the biggest challenges that we are dealing now about getting the stack into commercial license perspective. We are doing some tests in front of OpenBTS 3G implementation, if anyone is aware of it, so we can get some kind of a lab of doing the fallback as is.
Fallback to 3G.
Fallback to 3G and move back through 4G. And again, now we're also actually doing the same thing for the 5G, because what really interesting that although the IMS on 5G is almost looking the same, the EPC level of it, the services that you are telling them to prioritize your packets are different between the 4G and 5G. So you will need to do some kind of a fallback and fallback to between 3G to 4G, 4G to 5G, 5G to 3G, and etc. So yeah, it's a hell of a journey, but we are up to it. All right, any more questions? No? No? Well done, well done. So I hope we didn't mean to boring.
We do have like reviewed the OpenSIPS spec, if Razvan was here, about the templates and the...
Yeah, if anyone want to go to, I think that pretty much everyone are all well with information. If anyone want us to go over the CFG of the PCFF, ICFF, and SCFF, want to see the commit, how it's looking the CFG? You will puke on us with all of those.
No. Too many initials anyway for that.
All right, guys. So
you got off the hook, Razvan. Nobody wants to see your beautiful CFG file.
Good.
Yeah.
Show us your nipples instead.
Somebody take the bottle.
All right. So yeah. So anyone else have any question? Lorenzo, Alex, still class?
Conclude from your side.
It's open for the audience. So if there's any topic that anybody wants us to dive deeper into, real time or in our metrics channel, we're right here.
Great. So thank you very much again, Alexander and Lorenzo, for joining us. And yeah, I love those.
Great work. This is really amazing. I think what you put together is nothing short of amazing, and it's fun to see the technology that we work on actually find such a great use case. So yeah, thanks to you.
And see how amazing, how fast you were able to capture all those different protocols and unify them into one view.
It's a good test.
Yeah, great case study and great.
Now it's peanuts.
So, thank you everyone for a great day of workshops. If anyone else have any more questions?
You can write it the right time to summarize the day if you want.
I'm not the one doing that.
I think we need to do the pictures now, right?
Oh, the daily picture?
The OpenSIPS pictures we did. We are already late.
Half of the people left, so now the guys that left are the ones that will survive the picture, right? So let's get everyone here for
everyone to the front, please.
You know, Lorenzo, Alexander, if you want to join us to the picture in the background. Let me just check the layout here. You can come your head. I'll put you on the screen for a second. That will be a very cool thing. Amazing. Let me set it up.
Come on, guys. Let's take a picture.
Come on.
Everybody in front of the room. Hi, Alexander. Hi, Lorenzo.
Drinks? There's drinks?
See me?
I will get more cups.
Yeah, now you're at the top.
Yes,
come your head. Come your head. Turn on the light. Thank you, David. Thanks.
Come on, where's the green guy?
Ah, najdacie.
Beautiful. So we definitely have a volunteer camera.
Big ones at the back, little ones at the front.
Big one.
Come on, man. Won't be funny front.
Yeah, because the light. Connected in the ground.
Wait.
Yeah, just get in close. It's better. Don't stand at the side there. Get in close. Or you can step back.
Hey, cheese!
Cheers! Say OpenSIPS!
Say 503.
Now freestyle, good pace.
Run! He's still on the table.
Which is surprising afterwards. Yeah, exactly. He'll be dancing on a cold shore. Get right in the middle. Go in the middle. You're smaller, so you need to be in the middle. You actually catch everyone? Thank you. Yeah. Good.
Okay, say cheese. Cheese. Okay.
Who's having fun in this?
Yeah.
Yeah.
Okay, say cheese.
Cheese. Wait, one last. Wait, with this, of course. Are you ready? 5, 4, 3, 2, 1. Wait. Face the label, exactly. 5, 4, 3, 2, 1.
Okay.
Good.
Yeah.
Thank you very much.
The bar is open if you want to start by. Yes, good to meet you. I'm in Scotland. You're in Scotland. Thank you, Roberto. Alexander.
Thank you.
We're finished.